Hello and welcome. In this video, we're going to learn how to build a REST API to control products and categories with Node.js using Sequelize ORM and PostgreSQL database. If you don't know what is a REST API or are not familiar, there's a playlist here on the channel all about REST APIs from the fundamentals to advanced topics. I'll leave the playlist link on the description below. So Sequelize is a promise-based ORM for Node.js that allows developers to interact with Sequelize databases using JavaScript. It supports multiple databases like PostgreSQL, MySQL, SQLite, SQL Server, and many others. With Sequelize, we can define models, manage relationships, perform queries, and handle migrations without writing raw SQL. It also includes features like validations, hooks, transactions, and associations to streamline database operations. You can find Sequelize complete documentation and examples by visiting the official website, which is sequelize.org. And for this video, we're going to use PostgreSQL, a powerful open source relational database known for its reliability, scalability, and advanced features. It supports SQL, JSON, complex queries, and even extensions like PostGIS for geospatial data, and it's highly customizable. You can install Postgres on your personal machine by visiting their official website, which is postgresql.org, and click on Download, and you can select for which operation system you want to install. And to manage our Postgres database, we're going to use a platform called dbeaver, which is a free open source database management tool that supports multiple databases. It provides a graphical interface for managing databases, executing SQL queries, and visualizing data. dbeaver is widely used by developers and database administrators. You can download dbeaver by visiting dbeaver.io and click on Download. And you can download the dbeaver community version by selecting the operation system you want to install. And to test our REST API endpoints, we're going to use Postman, which is a popular API development and testing tool that allows developers to send HTTP requests, inspect responses, and automate API testing. You can download Postman by visiting postman.com and click on Product, then on Download Postman. It will already appear the operation system you're using so you can install. But feel free to use any other API testing tool you like. And lastly, for our code editor, we're going to use VS Code, which is a lightweight open source code editor by Microsoft, featuring built-in Git support, debugging, extensions, and intelligent code completion for various programming languages. You can download VS Code by visiting code.visualstudio.com. And on the homepage, it will appear the download button for your operation system. But once again, feel free to use any other code editor you like. So let's start by creating our Postgres database on dbeaver. And you could run PostgreSQL in a Docker container for easier setup and isolation, or even use a managed cloud database on AWS, Google Cloud, or Azure. But to keep things simple for this video, I'm going to use a local PostgreSQL installation. So on the first part of the video, we're going to create our database manually, but later we'll use a tool called Sequelize CLI to automate the process. This command line tool allows us to initialize Sequelize, generate models, create and run migrations, and see data, making database management more structured and scalable. So here on dbeaver, let's create a new Postgres connection. As you can see, there is no connection here on the left side. And to create one, we can click on the new database connection here on the top left. And note that there are a lot of databases here we can select. So let's select the PostgreSQL option here. Click on Next. And on the connection settings, the host we can leave as localhost. In the database, by default, usually when you install Postgres on your local machine, it created a database called Postgres. So we can leave Postgres here. And here on the username, Postgres also create a username typically named Postgres that has full privileges. But I created another user with full privileges as well called manfra.io. But if you didn't create a new user, you can leave as Postgres. And the password, which I added as password. Now let's check the connection by clicking on Test Connection button. Great, it showed connected. We can click on OK. And now we can click on Finish. And the new Postgres connection appear here on the left side. If we expand Databases folder, Note that it shows the default Postgres database here, but let's create a new database that we'll use during the video. So I'll right click on the databases folder and select create new database. And the database name, I'll add something like Sequelize _with Node.js. And the owner, since we connected with the manfra.io user, so I'll select here manfra.io. And here on the table space dropdown, we have three options: PG default, PG global, and default. PG default is the normal table space PostgreSQL uses. But depending on your setup, selecting it manually may require super user permissions, which can cause the beaver to show an error. PG global is only for PostgreSQL's internal system catalogs, so we should never use it for a user database. That leaves us with default, which simply tells PostgreSQL to choose the correct table space automatically. And behind the scenes, it still uses PG default, but without any permission issues. So for most cases, choosing default is the safest and recommended option. And now we can click on OK to complete. Great, here's our new Sequelize with Node.js database. Note that the Postgres database is highlighted in bold because it's the default database. To set our new database as the default, we can right-click and select Set as Default. Perfect. Later, we'll delete this database and recreate it using Sequelize CLI. Okay, so our database is created and now we can get started on coding. So I'll open VS Code. And I have an empty folder open here on VS Code called Sequelize with Node.js. And let's start by creating our Node.js project by opening the terminal here on the top and type npm init. And I'll add the -y flag to automatically accept the default values. Okay, project created, and we have a new package.json file with all the details of our app. We can change these details anytime. Now let's install the dependencies we'll be using. So back on the terminal, I'll type npm install, and we'll use Express to organize our routes, manipulate requests and responses to the client. And also Sequelize. And we need to install the database driver we'll be using. So here on the Sequelize website, we can click on Getting Started. Here it shows an example of the dependencies we need to install depending on the database. So for Postgres, we need to install the PG driver and also PG HStore. So PG is the official PostgreSQL client for Node.js, and PG HStore is a helper library for serializing and deserializing PostgreSQL HStore data type. Sequelize uses both libraries, so we need to install as well. Back on the terminal, let's add PG and PG-HStore. And to store securely our database connection details like host, username, password, let's use a dependency called .env that loads environment variables inside a .env file. Okay, we can hit enter. Perfect, dependencies installed, and we can check here inside the package.json file the dependencies we just installed under the dependencies object. Still, inside the package.json file, we have a property called main pointing to an index.js file. This will be our main file, the starting point of our application. We can change this to app.js or server.js, any name we like, but I'll leave as index.js. So we need to create this file on the root of our project. So here on the root, I'll create a new file called index.js. Okay, and since we're using .env dependency, I'll create our .env file here on the root as well to store environment sensitive information. So new file called .env. Great. So inside the .env file, let's store our database connection details like host, username, password, so we can pass later to Sequelize to connect to our database. So I'll add a comment here on the top by adding hash, database, configurations, for example. And I'll add the db_username variable. In my case is manfra.io, and the db_password, and the manfra.io password is password. The database name, so db_name, and we create it as Sequelize underscore with underscore Node.js. We can add now the host, so db underscore host. Since it's local, we can add as localhost. And the port, so db underscore port. And I'll add the Postgres default port, which is 5432. And since Sequelize can connect to multiple databases, so we need to tell Sequelize that we're using Postgres by passing a property called dialect. So let's create here the db underscore dialect equals to Postgres. Okay, that's it for the database configurations. And we might have multiple environments like development, staging, production. Each of these environments will probably have a different configuration inside this .env file. So for now, here on the top, let's add one more environment configuration variable. So I'll add a comment here saying environment configurations, for example. And let's define the port number which our application should listen. So I'll add here port equals to, and I'll add 3000, which usually is the port number we run our Node applications. But you can change this to any other available port. Soon we'll add other environment configuration variables here. And now we can start working on our index.js main file. So I'll just paste some lines of code here, because in every video here on the channel that I'm using Express, I'll just keep repeating myself setting up a basic Express server. Okay, so let's understand what's going on here. First, we're importing and initializing the .env dependency. Next, we're importing Express, and then we're starting on a constant called port, the port variable from the .env file, and this is how we grab the content from variables inside a .env file by calling process.env and the name of the variable. And if for some reason it's not on the .env file, we're explicitly adding port 3000 here by default. Next, we're initializing Express inside a constant call app. Next, we're telling Express to accept JSON data from the client. And last, we're starting our server by listening on the specified port we configure. And if everything works, we should see a message on the console saying server started on port and the specified port. Okay, very basic configuration for now. Now let's run the index.js file to see if our server is working. So back on the terminal, and to run the index.js file, we can run the command node index.js or just index. Hit enter. Great, server started on port 3000, and note that the .env library shows a tip here. These tips or log messages come from the newer versions of .env, which now include optional logging to help us developers understand what's being loaded. To avoid showing these tips, we can simply add an object here inside the config function and add the property quiet equals to true. This makes .env load silently with no logs. Let's test here on the terminal. I'll press Ctrl C to stop our index.js file from running and type again node index. Great, now we're not seeing any log messages anymore, only the server started on port 3000. Now before we proceed, every time we change something on our project, we need to stop our server here on the terminal by pressing Ctrl C and run again node index command. So let's install a development dependency that will keep listening for changes on our code and restart the server automatically for us. This dependency is called nodemon. So we could install nodemon globally or just on our application by running the command npm install nodemon, and I'll add a dash uppercase D flag to install as a dev dependency. Okay, nodemon is installed, and if we check inside the package JSON file, note that the nodemon is inside the dev dependencies object. So when we install the dependencies in another environment like production for example, only the dependencies will be installed and not the dev dependencies. These are meant to be used only in development. And to run our application using nodemon, note that inside the package JSON file we have a scripts property. Let me get rid of this test script here, and let's create a new one called start, which is equals to, so instead of running our application with the command node index, now we can run calling nodemon index. Let's test this script on the terminal. So to run this start script, we can type npm and the name of the script, which is start. Great, now NodeMon is listening for changes on our app and will restart the server automatically for us. Now let's create the necessary folders to organize our project structure. So here on the root, I'll create a new folder called controllers. And inside we'll store files to handle the application logic for each resource, like create, update, delete, categories, and products. Next, I'll create another folder called models, which will store files to define the database schemas for categories and products. Next, I'll create a new folder called routes to manage API endpoints and connect them to our controller files. And last, a new folder called config to store configuration files like database connections and other configurations as well used along the video. That's it for now, but later we might need to create other folders. So let's start by creating our database connection file inside the config folder because we need to use for our models. So I'll create a new file inside the config folder called database.js. And inside, let's start by importing Sequelize here on the top. So I'll add a new constant with an empty object equals to required Sequelize. And we're going to extract from inside Sequelize the Sequelize class. Now let's create a new instance of the Sequelize class we just imported. So I'll add another constant called Sequelize in lowercase equals to a new instance of the Sequelize class. And inside we need to pass the connection details that we defined here on the .env file for our Postgres database. So inside Sequelize class, I'll add an object, and let's start by configuring the username property, which is the db underscore username variable from the .env file. So process.env.db underscore username. Next, we can set the password property equals to process.env.db underscore password. Next, for the database name, we can set the database property, which is equals to process.env.db underscore name. Now we can set the host equals to process.env.db underscore host. The port also equals to process.env.db underscore port. And last, we need to define the dialect property equals to process.env.db underscore dialect. Great. And we could configure other properties here. For example, login property, which controls how SQL queries are logged. And here we can pass false to disable logging, or console.log, which is the default value for this property if we don't set anything. And this will print queries on the console log. Or we can add a custom function with parameters SQL and timing. The SQL parameter is the actual SQL statement executed, and timing is the execution time of that query. But to use the timing parameter, we need to set another property here on the Sequelize class, which is the benchmark property, and set to true. This custom function is useful if you want to store the query logs inside an external file or external application. For our example, I'll just leave the default, which is the console.log, just to see the queries on the console. Since this is the default, we could delete the login property, but I'll just leave it explicit here. And now we can remove the benchmark property as well. Okay, now all we need to do is export the Sequelize constant to use in other files. So I'll add module.export equals to Sequelize constant. Great, I'll just add a semicolon at the end of every line here to keep it consistent and standard. But this is optional, your code would still work without them. Now let's create our database tables So we could create directly here inside dbeaver by expanding our Sequelize with Node.js database, then schemas, then public, and right-click on the tables folder and select create new table. Or with a migration tool, which we're going to use later using Sequelize CLI. But for this first example, we'll let Sequelize create the tables automatically by our model files. Just a quick note here, PostgreSQL organizes objects inside schemas, and every new database comes with a default schema called public. So when we create a table here, it actually goes inside public, even if we don't specify it. That's why dbeaver shows this folder structure. So here inside the models folder, let's create a new file called category.js. And inside we're going to set the category table schema, and we're going to tell Sequelize to create the category table based on the category model file. So first thing we need to do is to import our database.js file from inside the config folder. So I'll create a new constant called Sequelize equals to require .. to go back one folder and select the config folder / the database file. Now we can define our category model schema. So I'll create a new constant called category. It's a good practice to create model names in upper camel case. And this is equals to the Sequelize constant we imported on the top, dot the define method. And the first parameter is the model name. So I'll add category, same name we added for the constant here. And the second parameter is the attributes. That means the fields that the category table will have. So this is an object, and it's a good practice to add a primary key in every table, which is a unique identifier for a record in a database table. It ensures each row is distinct and cannot be null. If we don't define any primary key here on the model attributes, Sequelize automatically creates a field called ID as a primary key and as an integer auto-increment value. But I'll add explicitly here to ensure consistency and better control of our model files. So ID, and this is equals to an object. Now we can define the ID attribute. So let's add the type equals to, and let's import an object from Sequelize called data types that provides various data types to define model attributes, ensuring compatibility with the underlying database system. So here on the top, I'll add a constant and an empty object equals to require Sequelize, and we'll extract the data types object. So back on the type property, let's call the data types we just imported dot, and note that we have all database types here. So we could add the ID primary key field as a UUID type to generate a unique ID, but let's add as integer because this will be an auto increment field. So for that, we also need to add the auto increment property, and this is equals to true. And the ID is the primary key field. So we can add the primary key property, also equals to true. And the ID field cannot be null or empty. So we can add the allow new property equals to false. Although we enabled the auto increment property here, so it will generate a new value every time we insert a new category. So it will never be null. But let's add this allow new property to maintain consistency. Great. Now let's add the name field equals to an object as well. And let's add the type equals to data types dot, and the name field on Postgres will be a varchar type. So here on Sequelize, we can select the string type, and by default, the length is 255 characters, but let's limit this to 60 characters, for example. So we can add a parameter here for the length. So we'll add 60 here. Okay, and let's make the name required as well. So we can set the allow new property equals to false. And for the categories, the name must be unique. That means we cannot add a category name that already exists. So in Postgres, we can set a unique constraint to the name field. So here on the model, we can add the unique property and set to true. And one of the benefits of Sequelize model definition is the ability to add custom validation rules for specific fields. These validations run before Sequelize attempts to save the data in the database. So for example, when we try to create or update an entry in the database, Sequelize will check these validation rules before saving the record. If any validation fails, a validation error type will be thrown. So we can add the validate property, which is equals to an object, and we can set built-in validators here. Like for example, the not empty validator, which ensures the value is not an empty string. And this is equals to an object, and we can set the message property to show a custom message to the client when the name is not informed. So let's send a message like name is required, for example. We can set other validators here, for example the contains validator to ensure that a string field must contain a specific substring, or the equals validator to ensure a string field must match exactly a specified value. We can set a minimal length to this field or a max length. So there are many validators we can set here. Now, since the name is required and the client must pass this field when trying to insert or update a category, there is a difference between an empty string and a new value. So we must set the not null validator as well. In the message property, I'll set the same as the not empty validator. So name is required. Later, when we'll test this, I'll show you the difference between these two validators. But for now, just know that empty and null are different validators. Great, so since the categories table will only have ID and name, so we're done for the validation rules here, and also for the fields definition. Now for the define method, we can set a second parameter, which is the options parameter. And we can set some properties inside an object. So when Sequelize creates the categories table by this model definition, it will create a table with the same name as categories, in capital C. Usually I like to create table names all in lowercase, so we can tell Sequelize how we want the table name to be called, by setting the table name property. So I'll add categories, all in lowercase. Great. Now in most apps, it's a good practice to track when each record was created and last updated, because it's useful for things like showing recently added items, sorting by last update, creating audit logs. So we could create these two fields manually here inside the model attributes, together with the ID and name. But we can add a property here on the options called timestamps and set to true that Sequelize will automatically add a created add and updated add fields. But it will create as camel case, where first words start with a lowercase letter and every new word starts with an uppercase letter. But it's a good practice to create table fields all in snake case, which all letters are lowercase and words are separate by underscore. So we can specify how we want timestamps fields to be called by setting created add property. So we can add created underscore at. And for the updated at, we want as updated underscore at. So Sequelize will create these fields on the database just like we added here. But what if we have other fields here on the model in camel case? Because usually in JavaScript, we prefer to work with camel case fields. So to make sure all field names are created with snake case, we can set here on the options a property called underscored and set to true. This property converts all field names from camel case to snake case in the database. Since it's going to convert all fields, so we can remove the created add and updated add properties from here. We could leave these properties if we want to change the name to created on or updated on, for example. Okay, so the category model is defined and all we have to do is export this so we can use in other files. So I'll add here on the bottom module.export equals to the category constant we defined it up here. Now we need to tell Sequelize to create the category table and its fields on the database for us automatically based on this model definition. We can do this on the index.js file. So first, let's import the Sequelize from inside the database file. So here on the top, I'll add another constant called Sequelize equals to required / the config folder / database. And below the express JSON middleware configuration, let's call this Sequelize constant dot, and we can use the sync method. This method creates the database tables based on our model definitions. It's great for development, but in production, it's safer to use migrations to avoid accidental data loss or schema issues. For now, we'll use the sync method just to get things up and running quickly. But don't worry, later on the video, I'll show you the proper way using migration, which is what we should use in production. This just helps us keep moving while we build things out. And the sync method returns a promise, so we can add dot, then, and inside a callback function. So if the sync method worked and our models are synced with the database, let's write a message on the console. So console.log, and I'll add database, connected, and synchronized. And let's only start our server if our database is synchronized. So let me cut this listen method from here and paste inside the sync method. Okay, but for the sync method to work, we need to import here the model files we want to synchronize with our database. So here on the top, let's import the category model, calling the required method directly without attributing to a constant. And inside, / select the models folder / the category model. Great, now let's save this. And great, so here on the console, it shows the SQL statements that the sync method executed. For example, the create table, categories, and the fields we defined on the model. And these logs are shown here because we configured console log here on the login property inside the Sequelize instance while creating our database connection. And it also showed the database connected and synchronized message and the server started on port 3000. Now let's check inside dbeaver. Let me right click on the tables folder and refresh. And perfect, here's the categories table, and if we expand, here are the columns with the ID as serial, which is a special type that auto-generates unique integers and automatically creates a sequence and assigns the next value to the new rows, because we define it on the model as auto-increment, and the name as varchar of 60 characters, and the created add and updated add using a snake case because we configured the timestamps and the underscored property as true. And if we expand the constraints folder, we have two constraints here. One is the unique constraint we created for the name field to make it unique, and the other constraint is the primary key for the ID field. So everything here looks correct and the Sequelize sync method worked perfectly. Now we can start developing the CRUD endpoint to create, update, read, and delete categories. So here on the controllers folder, I'll create a new file called category controller.js. And inside this file, we'll create functions like create category, update category, get categories, all functions related to CRUD operations. So let's start by creating a function to create a new category, and we'll expose this function so we can use inside other files. For that, I'll add exports, object, dot, and let's call this function create category. Equals to an arrow function. And inside, as a parameter, we need to add the request and the response parameters. These parameters are from Express. Request is everything the client sent to our API. And response is what we need to send back as a response to that client's request. And inside here, I'll add a try block and a catch block. And we can add a parameter here, which is the error. So if something went wrong inside the try block, we can catch the error inside the catch block. So let's write the error parameter on the console. So console.error. And since the error parameter is an object, so let's convert to string so we can see the entire error. So I'll wrap inside JSON.stringify function and add inside the error parameter. And let's also send a message and status code back to the client. So for that, I'll call return the response parameter from up here, dot status, and here we'll use the 500 status code, which means internal server error. If you want to learn more about these status codes, there's a video here on the channel explaining the concepts for REST API like methods, status codes, and much more. I'll leave the link on the description below. And we'll also send a JSON response, so .json, and we'll add an object with a message property, and I'll add something went wrong. It's not a good practice to send the error parameter back to the client. This is meant only for developers to see and track the error. So we're sending a more generic message here. Okay? Now inside the try block, we'll create a new category based on the information that the client will send through the request parameter from up here. So first thing we need to do is to import the category model. So here on the top, I'll add a new constant called category. Usually I like to add model imports in capital, equals to require, and inside // to go back one folder and select the models folder, / and select the category file. Now back on the create category function inside the try block, I'll add a new constant called new category equals to the category model we just imported, and we can use the create method. What this method does is add a new instance of the category model and call the save Sequelize method to save on the database. And as a parameter, it receives the data we want to save inside the categories table. So we can call the request parameter .body. So the client will send a JSON body to the request, and we're grabbing that request body and save on the category table. And since the create method returns a promise, so let's wait for this method to finish so we can execute the next line of code. For that, I'll add the await keyword here on the front. And now we need to make this function asynchronous by adding the async keyword in front of the function. Great, all we need to do is send back a successful response to the client. So I'll call return the response parameter .status, and here we can send the 201 status code, which means created. Every time we create a new resource, this is the correct status code we should send back to the client. And also a JSON response. And let's send the new category constant containing all details of the new category like ID, name, created at, and updated at fields. Perfect. Now we need to create the route that is going to call this function. So we're going to create inside a separate file inside the routes folder. So I'll create a new file here inside routes called category route.js. Inside this file, we'll create all routes related to categories, and all of them will call a function from inside the category controller file. So here on the top, let's start by importing the express router handler. So I'll create a new constant called router equals to require express, and here on the end I'll add dot and call the router function. And let's also import the category controller file. So const category controller equals to require .. to go back one folder, select the controller folder, / and select the category controller file. Now here we'll create the category endpoints like post, get, put, or patch to update and delete. So we're going to start with the create category that we just created. So I'll call router constant dot, and we'll use the post method. And the first parameter is the route name, so I'll add / categories. And the second parameter is the function that this route will execute when the client calls it. So we can call the category controller dot and select the create category function. Perfect. Now we need to export the route constant. So here on the bottom, I'll call module dot export equals to router. Great. Now we need to pass this router constant to express. So on the index.js file, below the express JSON middleware configuration, we can call the app constant.use method and import the category route file. So require /route slash and select the category route file. Now, one note here, since the category route file is using the category controller file, and the category controller file is using the category model file, so we don't need to import the category model file here anymore, since we're already importing the category route file here, which is kind of using and importing the category model file. So we can get rid of this required category from here. Let's save. And note here on the console, it shows a log message checking the tables that we already have on the database, but let's make sure the sync method will still create the category table after the changes we made. So here on the Beaver, let's delete the category table by right click and select delete just to make sure it will work. Okay, now let's just save the index file again. Great, the SQL statements was executed and database is synchronized. Now let's check on the Beaver again. Let me refresh the tables folder. And perfect, the category table is created with all the fields again. Now let's test the create category post endpoint on Postman. And let's create a new request by clicking on the plus sign here on the top. And the method here on the left, we can change it to post. And the URL, we can add http :// localhost column, and our server is running on port 3000. And the name of the route we created is /categories. Okay, now we need to add the data on the request body we want to send to create the category. For that, I'll select the body tab here, and then select the raw option. And the type of data we can leave as JSON. And for the body, I'll add an object. And the categories table have 4 fields. The ID, which is auto-generated by Sequelize, the created at and updated at, which will also be created automatically by Sequelize. So we only need to send the name of the category here. So I'll add name inside double quote column, and for this first category, let's add electronics, for example. Okay, we can click on send here on the top right. And perfect, we received 201 created status code and the new category details on the response body, which the ID is 1 and the name is electronics and the created and updated at with the current date. Perfect, and let's check here on the Beaver inside the categories table if the electronics category was inserted. So right click on top of the table and select view data. And great, here's the electronics category with ID 1 and the created and updated at fields. Perfect. Now let's create another category here. For example, I'll add accessories and click on send. Great, 201 created status code and the new category details on the response body. Now on the Beaver, let's click on refresh here on the bottom. And great, here's the new accessories category. Now let's test some validations here on Postman. So let's try to send an empty name here and click on send. So we got a 500 internal server error status code and an error message saying something went wrong. Now let's check here on the console. So this is the error object that we're writing on the console here inside the catch block of the create category function. And note that it sent a Sequelize validation error. And note the message property here saying name is required, exactly like we added on the category model validator for the not empty property. And note here the validation name is not empty. Now on Postman, let's remove the name property from here and click on send. Okay, we got the same status code and message. Now here on the console, again we got the Sequelize validation error, the same message, name is required, but now the validation name is null. That's because it fell here on the not null validation. So the difference between not empty and not null is that not empty validates if the name is not an empty string, and not null is if the name property is not being sent at all. We could of course change these messages here for each validation, but name is required seems appropriate for both. Now instead of sending a generic message like this to the client, we should send the message we set inside the model, which is name is required. And also another status code, because 500 means an error coming from the server. But in this case, it's an error coming from the client, because it's a validation error. So what we can do here on the catch block is check if the error parameter is an instance of the Sequelize validation error. And to check the error instance, let's add another console log here and call the error parameter .constructor .name. Let's test this request again. Okay, now on the console, here's the instance which is validation error. So back on the catch block, let's add an if statement and check if the error parameter is instance of the validation error, and let's select this here from Sequelize. And note that I already imported the validation error instance from Sequelize here on the top. Okay, so if it's an validation error, let's return and call the response parameter .status, and let's send the 422 status code, which means unprocessable entity. This means that something about the data the client is sending is invalid or doesn't make sense. And also a JSON response. So let's send an error property inside an object to inform the error type to the client. It's like a short name or short code. So I'll add here, for example, validation, error. Along the tutorial, we'll send other types of error. And let's also send a details property, which we can inform the field name that is invalid and a message informing the error. And we can make this an array of validation errors that we might have. So on the category, we'll probably just have the name error. But when working with products, we could have other fields with validation error like name, price, quantity. We'll see soon when working with the products model. So here we can call the error parameter, and note here on the console, it returned an errors array. And inside an object, the message property. And the path property, which is the field. So let's grab here the errors array. And let's use the .map method from JavaScript to run through the array. So as a parameter, we have the error object. So I'll add E for error, and then an arrow function. And let's return a field property, which we can get it from the E parameter, .path, and also a message property, which we can get it from the E parameter, .message. Okay, let me just format this real quick. Okay, and if it's not an validation error, it will send the generic message and the 500 status code. Great, now let's test these changes on Postman. I'll just click on the send here, and perfect, we got the 422 unprocessable entity status code and an error property saying validation error, and the details array with an object informing the field as name and the message name is required. Great, now let's add the name back here on the body, but let's leave as an empty string. Awesome, we got the same status code and the same response body. So our validation is working perfectly and we're sending the correct status code and response to the client. Now, what if the client tried to send a category name that already exists? Because remember, we set on the category model the name field as a unique constraint. So for example, let's try to add the electronics category again. Click on send. Okay, so we got the 422 unprocessable entity status code, the error as validation error, and the details array with an object with the field property as name, and the message name must be unique. And if we check on the console, we got a unique constraint error, but with the same details of a validation error. That's because here on the category controller file, if we type unique constraint error, and note here on the top that we imported the unique constraint error class from Sequelize. And if we press Ctrl key, you can see that unique constraint error class extends the validation error. This is why the unique constraint error looks similar to the validation error. It's okay if we send the 422 status code as a response, but there's a more appropriate status code to send in this case, which is the 409 conflict status code. The 409 status code is used when the request can't be completed because it would cause a conflict with existing data. So what we can do here inside the catch block is check if the error parameter is an instance of unique constraint error and send the 409 status code in that case. So above the if statement, checking if the error is an instance of the validation error, I'll add another if statement and check if the error parameter is instance of the unique constraint error class we imported on the top. If so, let's return the response parameter dot status and send the 409 conflict status code. And also a JSON response. Let's send the error type as conflict error instead of validation error, and the details property, this time instead of an array, we'll send an object, because Sequelize will only send one unique constraint error at a time. So if we had other fields as unique and try to set them, Sequelize will only send one object inside the errors array. So the field property, let's grab the first and only item on the errors array. So error dot errors array, and we can add square brackets and 0 inside to grab the first element of the array. And then the dot path property to get the field. And let's add the message property as well, equals to the error parameter dot errors, grab the first element, dot message. So this way we're sending the same response body if it's a validation error to maintain a standard. Okay, so let's test this again, back on Postman. Let's try to send the electronics category, so I'll just click on send. And perfect, we got the 409 conflict status code and the error as conflict error, and the details, an object with the field as name, and the message as the default message from Sequelize saying name must be unique. But let's change this message here as well, saying something like category already exists, something like that. Now we could change this here on the catch block, but that will be a little more complicated to deal with other tables with other unique fields on our database. So what we can do is here on the category model, instead of sending the unique property to true, we could set as an object instead and set the message property, just like here on the validates property. So let's add here something like category name already exists. Now let's test again on Postman. Let's leave electronics here and click on send. And perfect. Now we got the message as category name already exists. Of course, this message here is up to you, but now we're sending the correct status code and cleaner details to the client. Let's just make sure the other validations are working. So let's try to add an empty name again. Okay, all good. Now let's remove the name property. Click on send. Awesome. So we're finally done with the create category endpoint, sending the correct response to the client in case it was a successful request or if there were validations or conflict errors. Now let's create another endpoint to return all categories we have on the database. So back on the category controller file, let's create another function here. Let me just close the terminal and hide the create category function. And below here, I'll call export dot, and let's call this function get categories equals to async function, the request and response parameters, and inside the try block and the catch block with the error parameter. So here inside the catch block, let's just copy the 500 response from the create categories function, because in the get categories function, we won't need a validation or conflict error check, because the client won't be sending data to this request, and paste inside the catch block. Okay, now inside the try block, I'll create another constant here called categories to store all the categories we have inside the database. So this is equals to await the category model dot, and to get all categories we can use the find all method, which returns an array of category objects from the database. If no records are found, it simply returns an empty array. So it's safe to use without needing extra checks. So now all we need to do is return the categories constant to the client. So I'll add return the response parameter dot status, and here we'll return the 200 status code which means OK and indicates that the request was successful and the server returned the expected response. And also a JSON response with the categories constant inside. Great! Now let's create the get product route inside the category route file. So below the post route, I'll call the router constant dot, and this will be a get route with the same name as the post route, so slash categories. And as the second parameter, let's call the category controller file dot and select the get categories function. So the post categories route is to create categories and the get categories route is to retrieve categories. Okay, now let's test this new route on Postman. So I'll open a new request here and the method we can leave as get and the URL will be http // port 3000 / categories. Click on send. Great, so we got the 200 OK status code and an array of categories, the electronics and the accessories with all the details. Perfect. The get categories route is very simple. We don't need to test any extra validations here. Just note that if our database doesn't have any categories created, this route would still return the 200 status code and an empty array, which is the correct response, because the category resource exists, but it's just empty. Now we need to create a route to update an existing category. So below the get categories function, I'll call export dot, and we'll call this update category equals to async arrow function with the request and response parameters, just like on the other routes. And the try block and catch block with the error parameter. And let's copy the 500 error response here from the get categories function and paste inside the catch block here. But soon we're gonna add validation errors here as well. Now inside the try block, I'll create a new constant called updated category, which is equals to await the category model dot, and we can use the update method, which is used to modify one or more records in the database that matches a condition. And it takes two parameters. The first parameter is the values to update. So we can add an object here. And for the categories, the client can only update the name field because the ID is auto-generated, so it cannot be updated. The created ad field as well, and the updated ad will be updated automatically by Sequelize. So here, only the name can be updated. And we can get it from the request parameter .body .name. And the second parameter, we can configure some options inside an object as well. So in this route, we'll only update one category. So we need to add the where property here, which is used to filter records. It tells Sequelize which rows or row to find, to update or delete. And this is also equals to an object. And here we're gonna update by the primary key field, which is the ID. And the client will pass which category ID it wants to update in the route URL parameter. To get the parameter, we can call the request parameter .params object dot and the name of the parameter, which we're gonna configure soon inside the category route file. So we'll call ID. Great. For now, let's just console the update category constant just to see what the update method returns. So console.log the updated category constant. But let's convert this to a string to see the raw data here. So I'll wrap this inside JSON.stringify and the updated category constant inside. Okay? And for now, let's just send the status to the client, because later we want to send the details of the category after it gets updated. So return response.status, and here we can also use the 200 OK status code. And for now, we can just send an empty object. So .json and an empty object. We'll change this response soon. Now let's create the route to call the update category function. So on the category route file, let's create a new route here So I'll call router dot, and here we can use the put method or the patch method. Both are used to update a resource. The difference between them is that put is used to fully replace a resource. The client will send the entire updated object. And patch is used to partially update a resource. The client will send just the fields that needs to be updated. So since the client can only update the name field and will not send the full category object, so let's use the patch method here. And the name will also be slash categories slash, and here we can configure the ID parameter so the client can send. Remember, the ID parameter we configure inside the where condition. So to add a parameter, we can add a column and the name of the parameter, which is ID. And then call the category controller file dot and select the updates category function. Great. Let's test this new endpoint on Postman. So I'll open a new request tab here on the top, and the method will select patch, and the URL is http, the localhost, port 3000, / categories. And let's check what categories we have so we can update. So let's check here on the Git categories tab. And let's update the accessories category, which is 2. So here on the ID parameter, I'll add 2. And for this endpoint, we need to send a request body. So I'll open the body tab here and check the raw option. We can leave as JSON here. And on the body field, I'll add an object. And we can only update the name. So let's change the accessories to books, for example, and click on send. Okay, we got the 200 OK status code and an empty body response. Now let's check on the console. So we receive back an array with 1 inside. What this means is that one record was updated. So if we check on dbeaver, so here we have the old data where the ID 2 is still accessories. So let me refresh here. And great, the category was updated to books and the updated ad also changed it to the current timestamp. But let's send back the updated category details to the client. So here on the category controller file, inside the Sequelize update method, besides the where property, we can also set a returning property to true. This property tells Sequelize to return the updated rows after the update operation. But keep it in mind, this property will only works with PostgreSQL. So let's test this again, back on Postman. And let's update again the category with ID 2, which now is books, but let's update back to accessories. And click on send. Okay, once again, we got the 200 OK status code and an empty object. Now let's check on the console. Okay, so now the updates category constant is an array with the first element as 1, which is the number of rows that's being updated, same as before. And the second element is another array with an object containing details of the updated category. As you can see here, the name is now accessories. So this is the data we should send back to the client. And let's double check if the category was updated on dbeaver. So here we have the old data where the category ID 2 is still books. And if we refresh, now is accessories again. And the updated ad was also updated. So back here on the update category function, since the Sequelize update method returns an array, so we can destructure this array. So the first element is the updated rows count. So I'll add here updated rows. And the second element is the updated categories array. So I'll add updated categories. And let me replace this console log here to the updated rows constant, just so we can see how many rows were updated. And here on the response, we can replace this empty object to the updated categories. And since we're only updating one category, so this array will only have one object element. So let's grab the first element by adding index 0. Okay, let's test this on Postman. So let's update the accessories to books again and click on send. Great, we got the 200 OK status code and the updated category details on the response body. Awesome. Now, what if we try to update a category that doesn't exist? So for example, let's try to update a category ID equals to 10, which we don't have it on our database. And we can leave as bugs here for now. Click on send. Okay, we got a 200 OK status code and nothing on the response body. Now let's check on the console. So now 0 rows were updated because the category ID doesn't exist. So we need to send a better response here to the client, because sending like this, the client might not understand if the category was in fact updated. So here on the updated category function, what we can do is check if the updated rows constant is equals to 0. If so, we can send a different response to the client informing that the category doesn't exist. So above the response here, I'll add an if statement and check if the updated rows constant is equals to 0. If so, let's return a response.status, and here we can use the 404 status code, which means not found. We can use this status code if a URL is wrong or if the requested resource doesn't exist in the database, for example. And also a JSON response with an error property saying category not found. Okay, let's make sure this is working. So back on Postman, we can leave as 10 here for the ID parameter and click on send. Perfect. Now we got the 404 not found status code and the error message saying category not found. Perfect. Now, while this current approach using the Sequelize update method is solid and works great in many cases, there is a cleaner and more expressive alternative using other Sequelize methods. The update method is great if we want to update multiple records, which is called a bulk update. But for updating a single record like we're doing here, it's better to first fetch the category, check if it exists, and then update the fields. This way we'll get full access to the category instance. So let me comment all this code that we have here for now. And what we should do first is fetch that category where the ID is equals to the parameter. So I'll create a new constant here called category, and it's equals to await the category model dot, and since we need to fetch by the ID field, which is the primary key, so we can use the find by pk method, which means find by primary key, and it's used to find a single record by its primary key. So inside here we need to pass the ID value, which we can get it from the request parameter dot params dot ID. Now we can check if the category constant is empty. If so, that means no category was found with the given ID. So I'll add an if statement and I'll add an exclamation sign, then the category constant. If so, we can send the 404 status code and the error message informing that the category wasn't found. So I'll just copy the response we were sending from before and paste inside the if statement. Great, so the category constant holds an instance of the category, and to change the name, we can call the category, then .name, and attribute a new value here. So this is equals to the request parameter, .body, .name. And now we actually need to save the changes to the database. So below here, we can call await the category constant and use the .save method. This method is used to persist changes made to a Sequelize model instance back to the database. Now we could send the category constant that has been changed back to the client, or to make it more explicit, we can attribute the category save method to a constant here, and let's call this updated category, and actually send this constant instead. So below here, I'll call return the response parameter dot status, the 200 OK status code, and a JSON response, and send the updated category constant here. Like I said, we could send the category constant that will send the details updated, but here we just make an explicit. Now let's test these changes on Postman. So let's change the category with ID 2, and we'll change back to accessories. and click on send. Perfect, we got the 200 OK status code and the updated category details on the response body. Now let's try to update a category that doesn't exist. So I'll change the ID parameter here to 10 and click on send. Perfect, we got the 404 not found status code and the error message saying category not found. So it's working like before, we just made the code cleaner. It's up to you which way you want to handle the updates category route logic using the Sequelize update method or find by primary key with the Sequelize save method. Now we need to test some validations here, so back on Postman, let me change the ID parameter here to 2 again. And first, let's try to add an empty string here on the name and click on send. Okay, we got a 500 internal server error code and the generic response error saying something went wrong. That's because it failed here on the catch block and we're not handling any validation error. So we can actually copy the entire catch block from the create category function, the validation, and the unique constraint check, and paste inside the catch block here. Now let's test this again on Postman. I'll just click on send. Perfect, we got the 422 unprocessable entity status code and the error property saying validation error and the details informing that the field name is required. Let's try now to remove the name property here on the request body and click on send. Awesome, we got the same status code and same error. Now let's put the name back and try to update the category ID too with a category name that already exists. So let's try to update this to electronics and click on send. Perfect, we got the 409 conflict status code and the error property saying conflict error and the details informing the field property equals to name and the message saying category name already exists. So all validations here are working normally, but here on the code we have duplicate validations, and probably on the product controller file, which we're gonna create soon, we'll also have the same validations here. So what we should do is create a function to handle errors globally so we can reuse in other functions. So whenever we need to add more checks and validations, we should only change in one place. So let's create this function inside a new file and inside a new folder. So here on the root, let me just hide the folders we have open here. And I'll create a new folder called utils. And inside, I'll create a new file called error handler.js, for example. Of course, the name is up to you. And inside this file, I'll create a new constant called error handler. And this will be equals to a arrow function. So what we're creating here is a middleware function to pass in all routes. And this is an error handling middleware. And for this error handling middleware function, it takes 4 parameters. The first one is the error, which is the error object we're handling inside the catch blocks. And the second parameter is the request. The third parameter is the response. And the last parameter is the next. So let's say, for example, we have multiple middleware functions to be executed before reaching to the logic inside the route. We can call the next parameter to go to the next middleware. If there isn't a next middleware, it will fall inside the route logic. So in short, we should create error handling middleware functions like this when we want a central place to catch and manage all unexpected errors in our app. Now inside this middleware function, what we can do is copy the entire code here from the create category catch block and paste inside the error handler function. Okay, let me just format here. Great. Now all we need to do is export this function so we can use in other files and pass to Express. So on the bottom here, I'll call module.exports equals to the error handler constant. Okay, now since the error handler middleware function will be passing to all routes inside our app, so here on the index.js file, we can pass to Express globally. So let's import here on the top the error handler function we just created. So const error handler equals to require dot slash and select the utils folder, slash and select the error handler function. And now we need to pass to express after the route initialization here. So we can call the app constant dot use and inside the error handler constant. The reason why we need to pass after the route initialization is because Express only passes control to the error handler if an error happens after the middleware is registered. So if we place it before the routes, errors inside the routes will never reach it. Okay? Now here on the category controller file, we need to make changes to all these functions here. So let's start by the create category function. So on the catch block, we can remove all this code from here and simply call the next parameter and pass the error object inside. So we need to import this next parameter here as a last parameter inside the function after the response. So the next here will call the error handler function and the same for the get categories, add the next parameter, and on the catch block replace this to next and error object inside. And last, on the update category function, add the next parameter and replace all this code here to next and the error object parameter inside. Awesome, so the code looks a lot cleaner like this. And we need to cut the Sequelize error classes import from here and paste inside the error handler file here on the top. Okay, let's make sure all these changes are working. So back on Postman, let's test the create category request here. So let's create a new category called courses, for example, and click on send. Okay, we got the 201 status code and the new category details on the response body. Note here that the courses ID is 6, but we only have 3 categories, so why it's not ID 3? That's because every time we try to create an existing category and throw the unique constraint error, it generated a new auto increment value for the ID. Now let's try to send an empty name here. Click on send. Great, we got the 422 unprocessable entity status code and the validation error and details on the response body. Now let's try to add a category that already exists. So I'll add electronics and click on send. Perfect, we got the 409 conflict status code and the error informing the category name already exists. So all validations here are working normally. Let's test the get categories request here. Click on send. Awesome, we got the 200 OK status code and the 3 categories here on the response body. Now let's try to update a category. So let's update this last category we created. So I'll add here the ID parameter as 6 and we'll update to closes, for example. Click on send. Perfect, we got the 200 OK status code and the updated category details on the response body. Now let's try to send an empty name here. Click on send. Great, all good with the status code and response body. Now let's try to update to an existing category. So electronics. Click on send. Perfect, we got the conflict error. So everything is working perfectly. Awesome, so we create endpoints to create, read, and update categories. All we need now is an endpoint to delete a category. So here on the category controller file, let me just hide all these functions from here. And let's create a new function. So export dot, and we'll name this delete category. And this will be equals to async arrow function with the same parameters, request and response. And now we have the next parameter as well. And inside the try block and the catch block with the error parameter. And inside the catch block, we can call the next parameter and pass the error object parameter. Now inside the try block, I'll create a new constant called deleted category. And this is equals to await the category model dot. And here we can use the destroy method. This method is used to delete records from the database, and inside we can configure some options inside an object. For example, the where property to filter which records a query should affect. And this is equals to an object. So just like for the updates category function, the client will pass an ID parameter on the endpoint. So here we can delete by the ID field, which we can get it from the request parameter .params.id. And the Sequelize destroy method returns the number of rows deleted. So we can add a validation here and check if the deleted category constant. Actually, let me rename this constant here to make it more sense. So I'll rename to deleted count because it doesn't return the instance of the deleted category. And here on the if statement, I'll change it to deleted count. So if it's equals to 0, that means no records were deleted, probably because it doesn't exist. So let's return the same error that we're returning here on the updates category if the category ID does not exist, returning the 404 not found. And let's paste inside the if statement here. Okay, so now we can just return a successful response to the client in case the category was in fact deleted. So return response.status, and here we could return the 200 OK status code and a success message, for example saying category deleted successfully, but instead let's return a 204, which means no content. This means that the request was successful, but there's no content to send in the response, because we don't have the category instance anymore since it was deleted. This way the client knows the category was deleted and show any message it wants on the front end. And since we're not sending anything on the response body, just the code, so then we can call the .send method. Okay, now let's create the route that we'll call the delete category function. So here on the category route file, I'll add another route, so router dot, and this will be a delete method, and the name will be just like the patch updates category route. So slash categories slash the ID parameter, and then call the category controller file dot and select the delete category function. Great, now let's test on Postman. So I'll open a new request tab here, and the method now is delete, and the URL is http :// port 3000 / categories. And let's pass a category ID that we want to delete. So let's check on the Get Categories tab here. Let's delete the last category we created, which ID is 6. So here on the delete route, I'll pass 6. Okay, and click on send. Great, we received the 204 no content status code and nothing on the response body. Let's just make sure it worked by calling the Get Categories endpoint again. So here we have the old data with the courses category. Now if we click on send, perfect, the category courses is not there anymore. Now let's try to delete a category that doesn't exist. So I'll add 10, for example, and click on send. Great, we got the 404 not found status code and the message category not found. So everything is working on the delete route. Now we could do something like we did here on the updates category route. Instead of calling the Sequelize destroy method directly, we could find the category by the primary key, check if it exists, and then delete the category. So let me comment everything here and leave just the response. And I'll create a new constant called category. Actually, let me copy this code from the updates category function, the find by primary key method, and this if statement here returning the 404 if the category doesn't exist, and paste inside here. So if the category instance wasn't found with that ID, we are returning the correct response here, and if the category was found, we can call await the category instance. And from here, we can call the .destroy method. Like this, we actually have the instance of that category we want to delete in case we need. Let's just make sure this is working. So back on Postman, let's create a new category so we can delete. So I'll open the Create Category tab. And let's create the Games category, for example. Click on Send. Okay, so the new game category ID is 8. Let's just double check here on the Get Categories tab. Okay, here it is. Now on the Delete category request, let's add here 8. Click on Send. Perfect, we got the 204 no content status code and nothing on the response. And let's try to delete the same category ID since we don't have it anymore. Click on Send. Perfect, we got the 404 not found and the error category not found. So once again, it's up to you which method you prefer. Using Sequelize destroy method directly, then you won't have the category instance, or use the Sequelize find by primary key together with the destroy method. So you'll have the category instance. So we completed our CRUD endpoints for the categories, create, read, update, and delete routes, with validations and sending the correct response. But we could make this code a little better, cause here on the category controller file, every route we have an async function, the try and catch blocks, and on the catch block we're just calling the next parameter passing the error object. So instead of repeating this in every function, we can actually create a wrapper function, often called a async handler, that catches any errors from our async functions and automatically forwards them to express error handling middleware that we just created. That way our route handlers here stay clean and focused only on the logic they need to perform. So here inside the utils folder, I'll create a new file called async handler.js. And inside, I'll create a new constant called async handler, which is equals to a function. And as a parameter for this function, we'll actually pass the async function from each route. So here I'll add fn, which is short for function, and we need to access the request, response, and next parameters from the function we're passing here. So we can add another arrow function here with the request, response, and next parameters, and this is what we call a high order function, which is basically a function that returns another function. Great! Now inside the async handler function, since we're expecting a async function here as a parameter, we can call and wrap it inside a promise dot resolve, which will handle both async and regular function. So here we can actually call the fn function from the parameter with the request, response, and next parameters. And after the dot catch to get the error, and inside we'll add the next parameter. This ensures that any errors are caught and passed to the next parameter. So we don't need to repair, try, and catch blocks in every route. So all we need to do now is export the async handler function. So I'll call the module.export equals to the async handler function. Now back on the category controller file, let's import the new async handler function here on the top. So const async handler equals to require // utils folder and select the async handler function. Now for every function we need to wrap inside the async handler function. So here on the create category function, let's wrap this async function with the async handler. Okay, and we can get rid of the catch and try blocks from here, since our async handler is already handling this. Awesome, now the same for the get categories. Wrap inside async handler. Remove the try and catch blocks. Okay, now for the updates category function, async handler. Remove the blocks. Okay, let me just format this. And last, for the deletes category function, so async handler, remove the try and catch blocks. Perfect. Now let me remove all comments we have in these functions. Perfect, look how clean our code is now, and we're only keeping the logic inside the functions. The error handling is on a different file, and the async function also in a different file. Awesome, and before we test this again and making sure it's working, here on the category route file, all route names starts with /categories. So if we ever need to change this for something else, like section, groups, collections maybe, we need to change every route prefix. So instead of adding the route prefix here, we can actually add here on the index.js file. When mounting the route as a first parameter here, we can add the prefix. So I'll add here the /categories prefix and call the required category route file as a second parameter. So now we're telling Express that every route inside this file starts with /categories. So now we can remove from all routes here these /categories. Awesome, now let's make sure everything's working. So back on Postman, let's open the Creates Category Request tab, and let's add the groceries category, for example. Click on Send. Perfect, we got the 201 status code and the new groceries category on the response body. Let's try to create an empty category. Click on Send. Awesome, we got the 422 unprocessable entity status code and the validation error on the response body. Now let's try to add the electronics category that we already have. Click on Send. And great, we got the 409 conflict status code and the conflict error message. So all validations are working normally after the changes we made. Let's check the Git categories request. I'll click on Send. Perfect, we got the 200 OK status code and the categories we have on the response body. Now let's update the groceries category, which ID is 9. So on the updates category request tab, I'll add 9. And let's update to office supplies, for example. Click on Send. Awesome, we got the 200 OK status code and the updated category on the response body. Let's try to update with an empty name. Click on Send. Great, we got the 422 unprocessable entity status code and the validation error informing the name is required. Let's try an existing category, so electronics. Click on Send. Perfect, we got the 409 conflict status code with the conflict error informing the category name already exists. And last, let's try to update a category that doesn't exist. So I'll add 20 here, for example. Click on Send. Perfect, we got the 404 not found and the error category not found. Let's just check here on the Git categories request. So here we have the old groceries category, but if we click on Send, and now it's updated to office supplies ID 9. Let's delete this category, so here on the delete request, I'll add ID 9 and click on Send. Awesome, we got the 204 no content status code and nothing on the response body. Let's try to delete again. And now we got the 404 not found with the error message. So everything is working perfectly after all the changes we made, and we complete our endpoints for the categories CRUD operations. And we actually did quite a lot of things here to make our code better and organized. And now it's time to create the endpoints for our products. So let's start by creating our product model inside the models folder. So I'll create a new file here, called product.js. And inside this file, we'll define the product model just like we defined the category model here. We'll just add more fields. So what I'll do here is copy the entire category model definition and paste inside the product model file, just so we can win some time here. So the constant name here, we'll change it to product in capital P. And the model name here as well, product. And for the product table, it will also have an ID as primary key, auto increment, so we can leave this field here. The same for the name, but instead of varchar of 60 characters, let's increase this to 120. Okay, and we can remove this unique property here because the product name can be duplicated in some cases. And the validation here we can leave as it is because the product name is required. Now for the options object here, let's change the table name to products in lowercase. And we can leave the timestamp property set to true because the product table will also have the created at and updated at fields. And we can also leave the underscore property set to true because we want all fields name to be created in the database with snake case. And below here we want to export the product constant instead. Okay, now we can add more fields here to compose the product table. So for example, we can add a description field and it's equals to an object. And we can make the description as a string without length limit. So in Postgres, we can define this field as a text type instead of varchar. So let's add the type property equals to data types that we already imported on the top, dot, and select the text type, which, like I explained before, is used to store large strings without setting a length limit. And the description field can be optional. In this case, we don't need to set the allow new property. Next, we can add a price field equals to an object. Now, there are a few good ways to define a price field in Postgres, depending on the level of precision and formatting we need. We can define as a numeric type, depending on the app requirements. We can define even as an integer or big int and store in cents. A lot of payment gateways store like this. We can define as float. Postgres has a type called money as well, but for our API, we'll define as a decimal type, which is basically the same as a numeric type. These types are used to store numbers with a fixed number of digits before and after the decimal point. The difference between these two types is that the decimal is an alias for numeric, but with a different default precision and scale values. So here, let's add the type property equals to the data types, dot, and we can select the decimal type. And inside parentheses, we can define the precision and the scale. So let's add here 10 for the precision, which is the total number of digits allowed, and 2 for the scale, which is the number of digits after the decimal point. So this means that we can store up to 10 digits total, with 2 of them after the decimal point. And the price cannot be null, so we can set the allow new property equals to false. And let's add some validations here, so we can add the not empty and not null properties. So let me copy the validate object here from the name field and paste here inside the price field. And for the messages, we can rename this to price is required. And here for the not null validation as well, price is required. Now let's add a validation here to make sure the client is passing the price as a decimal value and not as a string or a boolean, for example. For that, we can set the is decimal validation also equals to an object, and let's add the message property. And here we can add something like price must be a valid decimal number. This validation also allows integer values and negative values as well. But we don't want the client to inform a negative value here. We may allow 0 if we want to add as a gift maybe, but definitely not a negative price. So for that, we can define the mean validation, which is used to ensure a numeric field has a minimal value. This validation works with number types like integer, float, numeric, or decimal like we said here. So this is also equals to an object. And here we can define what is the minimal value for the price by setting the arguments property, which is equals to an array. So other validations may accept more than one argument here, but for the minimal validation, it only accepts one. So we could, for example, add the mean value here to 0.01. So that means the minimal price value is 1 cent. Or we can leave as 0 here, like I said, in case this product is a gift or a promotion maybe. So let's leave 0 here. And we can also inform the message property in case the client sends a negative number or less than the minimal value we set here in the argument. So let's add something like price cannot be negative. Okay? We can also add a max validation here to set the maximum value for the price. Or a len property, which takes 2 arguments, the minimal and the maximum values. So we could add other validations here depending on our API rules. Perfect, so the price definition is complete. Now let's add another field here, which is the currency field. So we can inform if this product is in dollars or euro or Brazilian real. So the client might add a product in dollars and the same product in euro, for example. So this is why we did not set the name field as unique. So this is equals to an object, and the type property is equals to data types. And this code follows a ISO 4217 standard, which defines a 3-letter code for each currency. The first 2 letters often match the country, and the 3rd letter represents the currency. So we can select as a string type with length of 3. Great, and we'll make this field required as well, but instead of adding the allow new property, we can set a default value for this field if the client doesn't send this field on the request. So we can add the default value property, and if the client doesn't send this field, we can set a USD, which stands for United States dollars, as a default value. And even though we're setting the default value property, we still need to configure the allow new property and set to false, because the client can send explicitly the new value, and according to our application rules, we cannot accept new value for this field. Now let's say, for example, our API only allows United States dollars, Brazilian real, and Indian rupee as currency codes. So let's add the validate property here, which is equals to an object, and we can set the isIn validation. This validation checks if the value exists in a specific list of allowed values we can define. So this is equals to an object as well. And we can set the arguments property, which is equals to an array. And the isIn validation is designed to accept multiple arguments, even a function, for example. So inside this array, we need to add another array and set the allowed currency codes inside. So here, let's add the USD, United States dollars, and the Brazilian real, which is BLR, and the Indian rupee, which is INR. Perfect. Now we can set the message property, and if the client doesn't send a currency code that is not on the array, we can send something like currency must be USD, BLR, or INR. Great. So if the client doesn't set the currency property, it will add by default the USD code. And if the client tries to send an empty string, it will fall inside the isIn validation here. In this case, we don't need to add the not empty validation. But if the client sends null explicitly to this field, Sequelize will show a message saying currency cannot be null because we set the allow null property as false. But let's send a custom message. So we can set the not new property equals to an object with the message property. And let's add something like currency cannot be null. We could of course send the same message we're sending here on the isIn validation, but let's send a different message to the client in this case. Okay? Next, let's add a quantity field, which is like the quantity the client have in stock, and the type property will be integer, so data types dot integer type. And let's also add a default value here of 0, because the client may want to register the product first before actually receiving in stock. And since the quantity cannot be null, so let's add the allow null property and set to false. Now let's add some validations here. So since we set the allow null as false, let's add the not null validation and the message property saying quantity cannot be null. And let's also add the minimal validation like we added here on the price to not accept values less than 0. So let me copy from here and paste here on the quantity field. And instead of price, let's replace to quantity. So quantity cannot be negative. Now, depending on the product, the client may store decimal quantities instead of integer. For example, weight-based products, liquid measurements, or construction materials, or many other cases. We'll set as integer, just to make it simpler, otherwise we'll also need to create a unit field as well, because the quantity might be in kilograms, liters, grams. So for our API, the quantity will be integer. So let's add a validation to check if the client is in a valid integer value. So for that, we can set the isInt validation, and we can set the message property, saying something like quantity must be a valid integer number. Perfect. Next, we can add the active field to indicate if the client is still working with this product. So this will be a Boolean type. So let's add the type property equals to data types dot Boolean type. And let's add a default value and set to true by default. So if the client doesn't set the active property, our API will assume that this product is active to the client. And since we won't accept new values, so we can set the allow new property to false. Now for the validations, let's set the not new validation with the message property saying active cannot be null. And we should validate if the client is sent a valid Boolean value. So we can set the is Boolean validation. And you might notice that this is not appearing in the IDE's autocomplete list. The reason for this is that Sequelize doesn't explicitly list is Boolean as a direct validation in its model definition. Therefore, Sequelize uses a famous library called validator.js under the hood, and the isBoolean validation exists within this library. So Sequelize will correctly delegate this validation check to the isBoolean function provided by the validator.js library, and here we can set the same way we set the other validations. So equals to an object, and we can also set the message property, and let's add something like active must be a valid Boolean value. Awesome! You can check the complete validator.js documentation by visiting their GitHub repository, which is github.com/validator.js/validator.js. Okay, and last we need to set the category field, which will store the category ID and establish a relation between the product table and the category table. So here we can set the category ID field equals to an object, and the category ID on the category table we set as an integer. So here we need to set the type as integer as well. So data types dot integer. And we won't accept null values here, so a product must belong to a category. So we can set the allow new property to false. Now to establish the relation with the category table, we can set the references property, which is equals to an object, and inside we can configure the model property, and here we need to set which model this field is relating to. So here on the top, let's import the category model file. So const category, and like I said before, I like to import model files in capital, equals to require. Since we're already inside the models folder, so I'll just add // and select the category model file. Now back on the model property, we can simply call the category model we just imported, and we also need to configure the key property, and here we need to set which field from inside the category model we're relating to. In this case is the primary key field, which is the ID field. Awesome, Later, we'll set other configurations to this field, and let's add some validations here. So here we can set the not empty and the not new validations. So let me copy here from the name validation and paste inside the category ID. So instead of the name, we replace to category ID, and here as well, category ID is required. Okay, let's leave just these validations for now, but we might add other validations here when we start testing. Great, so the product model is complete for now, and we can start working on the controller file to manipulate products. So let's create the product controller file inside the controllers folder. So new file, and let's call product controller.js. And just like for the category controller file, we're going to create functions to create, read, update, and delete products. And let's start by importing the product model file here on the top. So const product equals to require, then the / models folder / and select the product model file. And let's also import the async handler file. So const async handler equals to require / utils folder / and select the async handler file. Okay, and let's start by creating a function to create products. So just like we did on the category controller file, I'll add exports dot, and let's call this function create product equals to the async handler, and inside an async function with the request and response parameters. And inside this function, we just need to grab the data declining sending on the body request and insert in the product model, just like we did for the create category function. So I'll create a new constant, call new product equals to await the product model, and we'll use the .create method and simply pass the request parameter .body. And now just send a response to the client informing the correct status code and the new product details on the response body. So I'll call return the response parameter .status, and here we'll use the 201 created status code and a JSON response with the new product constant. And that's it. We're already handling all the errors inside the error handler file, so now our route will be simple and clean. Now let's create the route to call this create product function. So we need to create a product route file inside the routes folder. So new file, and we can call this product route.js. And similar to the category route file, let's start by importing the router function from Express. So const router equals to require, and inside express, and here on the end, we'll invoke the .router function. And let's also import the product controller file. So const product controller equals to require, and inside / controllers folder, and select the product controller file. Perfect, now let's create the post route that we'll call the create product function. So I'll call the router constant, and this will be a post route, and the name will be /products, but we're gonna add the /products prefix when configuring the products route on the index file, just like we did for the category routes. So here we can leave just /, and the second parameter we'll call the product controller file dot, and select the create product function. Great, now all we have to do is export the router constant. So here on the bottom, I'll call module dot export equals to the router constant. Perfect. Now let's initialize this product route file inside the index.js file. So below the category route initialization, I'll call app.use, and the prefix for the product route will be /product. And for the second parameter, we'll import the product route file, so require, and inside /routes folder, and select the product route file. Great, now before we save this file, let's open the terminal here on the top, and let's save the index file. And note that Sequelize is logging the SQL statement to create the products table. Let's check on dbeaver. So I'll right click on the tables folder and select refresh. Perfect, here's the new products table with all the fields we configured in the model file, separated by underscore, including the created and updated add fields. Perfect. Now let's test this new create product route on Postman. So I'll open a new request here on the top. And the method, I'll select post. And for the URL, we can add HTTP, column / localhost, and port 3000 / product. Now let's send a request body, so I'll open the body tab and select the raw option. We can leave as JSON here, and inside the body input, I'll add an object. And for the products, we can send the name property, which is required. And here, I'll add laptop, for example. And let's add a description, which is optional, but for this first example, I'll add something like this is the laptop description. Okay, now for the price property, I'll add something like 399.99 cents. Okay, now the currency we added by default United States dollars. So for this first example, I'm not going to add the currency property. So then we can add the quantity property. And for the laptop, let's say we have 10 in stock. Now for the active field, we also added a default value equals to true. So I won't be passing this property as well. And last is the category. So I'll add category ID in camel case. And let's check which categories we have again. So here on the Git categories tab, let's just click on send. Okay, so let's pass the electronics category, which ID is 1. So back on the create product request, we'll add the category ID as 1. Great, now we can click on send. Perfect, we got the 201 created status code and the new laptop product details on the response body, ID as 1, the currency as United States dollars, active as true, created and updated add fields, and all the other details we informed. Great, let's just double check inside dbeaver, and I'll right click on the products table and select view data. And great, here's the laptop product with all the data we inserted. So for now, our create product endpoint is working. Now let's test some validations here. So first, let's remove the name property from here and click on send. Great, we got 422 unprocessable entity status code and the validation error details inform that the name field is required. Now for example, let's also remove the price property, which is also required, and click on send. Great, so now we receive on the details informing that the name and the price is required. This is a good approach to show all the validations error at once, because the front end can highlight the inputs that required attention. And if we also remove the category ID, for example, and click on send, it will also show here on the details array. Now let's test other validations. So I'll add all these properties back here. And let's add the price value equals to a negative number. So I'll make this price negative by adding a minus symbol here on the front and click on send. Great, we got again the 422 unprocessable entity status code and the validation error saying that the price cannot be negative. Now let's add a string here, for example. So I'll add test and click on send. And now we receive that the price must be a valid decimal number. And for example, if we add a decimal number inside a string, so 100, for example, inside double quotes, and let me change the name here to keyboard, for example, and remove the description. The quantity and category we can leave as it is, and click on send. Great, it created the product, so that means Sequelize converted the string successfully to a decimal. So it also accepts like this. And note that we don't need to format the price, we can simply send an integer value that Sequelize will also convert to decimal here. Awesome. Now let's try to add a negative quantity and click on send. Great, we got 422 status code and the validation error saying quantity cannot be negative. Okay, let me remove the minus from the quantity. And now let's check the currency field. So I'll add a currency property here. And our API only accepts United States dollars, Brazilian real, and Indian rupee. So for example, if we try to add euro, so EUR, and click on send. Perfect, we got the validation error informing that the currency must be USD, BLR, and INR. Okay, now for the active field, we added a validation function that is not available inside Sequelize, but it's available inside the validator.js library, which is the one Sequelize uses on the background. So I'll add the active property, and let's try to send as test, for example. Click on send, and we got the validation error informing that the active must be a valid boolean value. And if we try, for example, a number, so I'll add 3. Okay, we got the same response, but if we try to add as 1, and let me change the name here to monitor, for example, and let me remove the currency property to avoid other validation errors. Now let's click on send. Okay, it created the product, and the active field set it to 1, it accepted as a true value. And if we change to 0, for example, and let me change the name here to camera, and click on send, this will accept as a false value. So the isBoolean validator will consider the string representations of the boolean values and their numeric equivalent to be valid. Now, one last validation we need to test is if we try to add a category ID that doesn't exist. So for example, I'll add 20 here and click on send. So we got a 500 internal server error and the generic error message saying something went wrong. So we should definitely handle this validation and send a better response to the client. To handle this kind of validation, if we check here on the console, it throws a foreign key constraint error. So we could handle this error type here on the error handler file by adding another if statement and check if the error is an instance of the foreign key constraint error and use the details here to generate a custom response to the client. But the foreign key constraint error is a broad error that covers multiple database integrity violations related to foreign keys. For example, besides trying to insert a record with a non-existing foreign key, like we did now, it also throws when trying to delete a parent record that's referenced by another table. So instead of checking if it's an instance of the foreign key constraint error, we could add a validation directly on the product controller file inside the create product function, checking if the category ID exists before inserting the product. Or we could create a custom validation here inside the product model file, directly inside the validate object of the category ID field. So let's add a new custom validation here inside the validate object, and we can add any name we want for this validation. So let's call this category ID exists, for example, and we can add a parameter here called value, for example, which is the category ID the client is sending. So we can handle inside here. Although this looks like a function or a method, in Sequelize context, it's more precise to say that this is a custom model level validator. This is the term that Sequelize calls for custom validators. So inside here, all we need to do is check if the category ID exists in the category table, and if not, throws a new error message. So we already imported the category model file here on the top, and inside our custom validator function, I'll create a new constant called category equals to await, and call the category model we just imported dot, and we can use the find by primary key method and pass the value parameter which holds the category ID. And since we're using await here, we need to add the async before the category ID exists validator. And now we need to check if there is a category with that ID. So I'll add an if statement here and an exclamation sign, the category constant. So if it doesn't exist, we can throw a new error, and inside I'll add backticks, and let's send something like category ID, and I'll add a $sign and curly braces, and inside the value parameter, and then does not exist. Okay, now when Sequelize runs this validation, it will send an instance of validation error, and it will fall inside the error handler function, inside the if statement, checking if it's an instance of validation error. Great, let's test this new custom validation, so back on Postman. We already sent in a category ID that doesn't exist here, so I'll just click on send. Perfect, we got the 422 unprocessable entity and the validation error informing that the category ID 20 does not exist. Okay, now depending on our API validation rules in this situation, you might want to send a different status code here, for example the 404 not found. To do so, we could not add this validation inside the model file directly. So we would need to create this validation inside the create product function, and then send just this error and another status code. But personally, I like to send as a validation error, because let's say for example the client is sending another incorrect data here. So let's remove the name property and the price as well. And then when we click on send, so we're sending all validation errors in one response, instead of sending just one at a time, avoiding the client to request our API endpoint multiple times till all validations pass. So in only one response, the client can fix these issues and try to create the product again. Perfect, so the create product endpoint is complete. And now let's create a new function to return all products we created. So below here, I'll create a new function, so export, and let's call this get product equals to the async handler, and inside the async request and response parameters, arrow function, and inside I'll create a new constant, call product equals to await the product model. And here we can use the find all method. Very simple. Now all we need to do is return the products constant back to the client. So I'll add return response dot status, and here we can use the default status code, which is 200, okay, and a JSON response with the products constant. Great. Now let's create the route that will call this get products function. So here on the product route file, below the post route, I'll call router dot, and this will be a get route. The name will also be the same as the post route, so I'll just add a slash here. And the second parameter, we can call the product controller file dot and select the get products function. Okay, now let's test this new route on Postman. I'll open a new request here, and the method we can leave as get, and the URL is http / localhost port 3000 / product, and click on send. We got the 200 OK status code and all products we added to our database. Great. Now, note that we have the category ID field here, but the client might need the name as well to avoid other endpoint calls. So instead of just sending the category ID property, let's send an object called category with the ID and the name as well. So back on the product controller file, inside the get products function and inside the find all method, let's add an object here, and inside we can add the include property, which is used to get related data from associate models. And this is equals to an array, and I'll add an object, and inside we can add the model property, which is the model relating to the product, in this case the category model. So we need to import here on the top the category model file. So below the product model import, let's add const category equals to require // select the models folder / and select the category model file. Okay, now back on the include array, we can assign to the model property the category model we just imported, and we can add an alias for this object by adding the as property, and let's call this object category. And since we just want to return the ID and the name of the related category, we can set the attributes property, which is equals to an array, where we can specify the fields from the category table we want to return. In our case, it's the ID and the name fields. Perfect. We can configure other properties here, like the where property, in case we want to specify a condition for the categories table. But let's leave just these three properties since we're only returning one category here. Okay, now let's test this on Postman. So here on the get products endpoint, I'll click on send. And note that we got a 500 internal server error status code and the generic response error. Let's check on the console to see what happened. And Sequelize throws an eager loading error. This error happens when Sequelize tries to load a related model using include, but it doesn't know how the two models are connected. In other words, the association is missing or not defined correctly. That happens because when we use the include property to fetch data from a related model, Sequelize needs to know how the tables are connected. Even though we already created the category ID column and reference the category model in the database, this only creates the foreign key at the database level. Sequelize itself doesn't automatically know the relationship between product and the category. So we need to explicitly tell Sequelize that a product belongs to a category by setting up the association. So down here on the product model definition, let's call the product model dot, and we can set the belongs to method. And the first parameter is the model that the product belongs to. In our case is the category model, which we already imported up here. And the second parameter is an object where we can set the foreign key property. And this is the field from the product table that is related to the category table. In our case, it's the category ID field from the product model. And we also need to set an alias here by setting the as property, and we'll refer to the relation using an alias called category. Great! Now Sequelize knows how to construct the proper SQL join statement and fetch both products and their associated categories in a single query. Now let's test these changes on Postman again. I'll just click on send. Perfect! Note that now for each product we have an object called category with the ID and the name of the related category. Awesome, but note that we're still sending the category ID field here, which the client might not need anymore, since we're already sending the category object with more properties. So we can exclude this property from here. To do so, let's go back to the product controller file. Above or below the include property, we can set the attributes property. This is the same attributes property we set here inside the include, but this time we can set an array of fields we would like to return from the product model. But instead of adding all fields here and just exclude the category ID, we can set this equals to an object, and configure a property called exclude, which is equals to an array. And inside, we can set the inverse. That means the fields from the product model we do not want to return to the client. In our case, it's the category ID field. Perfect. Let's test this on Postman just to make sure it's working. As you can see here on the response, it shows the category ID field. But if we click on send, great, now the category ID field is not there anymore, leaving just the category object. Perfect, so we completed the get products endpoint. Now the client might need an endpoint to return details for only one product. So let's create this endpoint where the user can inform the product ID on the route as a parameter. So below the get product function, I'll add export dot, and let's call this function get product by ID equals to the async handler, and inside async, the request and response parameters, arrow function, and inside the code will be similar to the get product function. So let's copy the entire code from here and paste inside the new get product by ID function. But now, instead of returning multiple products, we're just going to return one product. So we can rename this constant here to product. And instead of using the find all method, which returns an array of products, we're going to use the find by primary key method. So the first parameter of this method is the product ID we want to find. And since the client will pass the ID on the route as a parameter, so we can call the request parameter .params .id. And the second parameter, we can leave the attributes property with the exclude property inside, and the include property as well to return a category object with the ID and the name. And here on the return statement, instead of products, we're going to return the product constant. And above here, let's add a validation checking if the product exists. If not, let's return a 404 not found status code with an error message to the client. So I'll add an if statement and add an exclamation sign and the product constant. So if the product does not exist, let's return the response parameter .status with the 404 not found status code and a JSON response with an error property saying product not found. Great. Now let's create this route on the product route file. So below the get route we already have, let's call the router constant dot, and this will also be a get route. And here the client will send the product ID. So I'll add slash column, and the controller is expecting a ID parameter. And then we can call the product controller dot and select the new function get product by ID. Okay, let's test this new route on Postman. So I'll open a new request tab, and we can leave the get method here. And the URL is http://localhost and port 3000 /products. Let's add a slash here on the end, and let's add the product ID 1. Click on send. And perfect, we got the 200 OK status code and the laptop product details here on the response body with all the details including the category object with the ID and the name. Now let's change here to product ID 2 so we can check. Click on send. And perfect, we got the same status code and the keyboard details on the response body with the description as null and all other details. Awesome. Now let's add a product ID that doesn't exist. So I'll add 100 for example. Click on send. And perfect, we got the 404 not found status code and the error message saying product not found. So we completed the get product by ID endpoint, which is a REST best practice. It makes our API clear, organized, and easy to use for fetching detailed data of a specific product. we can create a similar endpoint for the categories to return details of a single category by its ID. Now that you implemented for the products, you should be able to create this one easily too. Now we need to create an endpoint to update products. So let's create the function for this inside the product controller file. And let me hide all the other functions we have here. Okay, and let's create a new function below here. So export dot, and let's call this update product equals to our async handler function, and inside async the request and response parameters, arrow function, and inside we're gonna do something similar to the update category function. So let me open the category controller file, and here we're getting the category by its ID, then checking if it exists. If it does, we're assigning the name that the client is sending on the request body, then we're saving the category instance inside a constant and sending back to the client the updated category. And remember that the validations are done inside the model file. So here on the update product function, since the client can send multiple fields like the name, description, price, quantity, and others, we're gonna use the Sequelize update method instead. So we're gonna start the same way by getting the product by its ID and checking if it exists. So I'll create a new constant here, call product equals to await the product model dot, and we're gonna use the find by primary key method, and the client will be sending the ID of the product on the route parameter, where we can get it by calling the request parameter dot params dot, and we're gonna call this parameter ID. Now let's check if the product exists, so I'll add an if statement and an exclamation sign, then the product constant. So if the product wasn't found, let's return a response to the client. So return response dot status, and we're gonna return the 404 not found status code, and also a JSON response with an object, and inside the error property saying something like product not found. Okay, and if the product was found, I'll create a new constant called updated product equals to await the product constant dot, and we're gonna use the update method. Now note that there is a difference between calling the update method from an instance of the product like this and call the update method directly on the model. Using the model.update method, the update happens directly in the database without loading any model instance. It only returns the number of affected rows. If you want the updated data, you can enable it by setting the returning property equals to true, but this is only supported in PostgreSQL. On the other hand, using the instance method product.update, like we're doing it here, you will update that specific instance, returning the updated object, and it's generally more readable and object-oriented, especially when you're already working with the model instance. And inside this update method, we can set the data that the client is sending on the request body. So I'll just add here the request parameter dot body, simply as that. Now all we have to do is return the updated product constant back to the client. So I'll call return response dot status, and we're gonna send the 200 OK status code and a JSON response with the updated product constant. Great. Now let's create the route that we'll call the updated product function. So inside the product route file, I'll create a new route here below the get by ID. So router dot, and we'll use the patch method here because we can update just one or all fields from the product model. And inside here, we're gonna add slash column ID parameter, and the second parameter we'll call the product controller dot, and call the update product function. Perfect. Now let's test this new endpoint on Postman. I'll open a new request tab, and the method here will change it to patch, and the URL I'll add http:// column / localhost port 3000 / products. And for the ID, what I'll do is create a new product so we can update. So back on the create product tab here, inside the body tab, I'll add the name property because it's required. And I'll just add as test, for example. And I'll also add the price property, which is also required. And I'll set it equals to 100. The quantity we can leave as 10, and we can remove the active property since the default is true. And for the category ID, I'll just leave as 2, which is the accessories category. Okay, we can click on send. And perfect, product is created with ID 6. Now back on the update product tab, I'll add here as a parameter the product ID 6. And on the body tab, I'll select the raw option and leave as JSON. And on the request body, I'll add an object. And let's add a description here, since we created this product without a description. And I'll add something like this is a test description. And click on send. Perfect, we got the 200 OK status code and the updated details on the response body. Here's the description we added. Now let's change other fields here. For example, the price, let's update. So I'll remove the description and add the price property. And let's try to add a string here to test. So I'll add as test and click on send. Great, we got the 422 unprocessable entity status code and the validation error informing the price must be a valid decimal number. So the validations are working. Let me try to update to 50.99 cents and click on send. Perfect, here's the price updated. And let's try to update the currency field to a currency that we're not accepting for now. So below the price, I'll add currency. And remember, for the currency validation inside the product model, for now we're only accepting United States dollars, Brazilian real, and Indian rupee. So here on the currency, let's try to add euro for example. And let's update the price again, so 70 euros for example. Click on send. Great, we got the error message informing that the currency must be USD, BLR, and INR. So let's change it here to Brazilian real, which is BLR. Actually, I just realized I made a mistake here. Brazilian real is not BLR, it's BRL. So let me just fix this inside our product model file. So here on the currency validations, inside the arguments array, let's change to BRL. And also on the message property here, BRL. Okay. Here on Postman, let's change to BRL. Okay, we can click on send. And perfect, the price and the currency were updated. For the last validation, let's try to update the category of this product to a category that doesn't exist. So let me remove all these properties from here. And I'll add the category ID equals to 100, for example. And click on send. Perfect, we got the 422 unprocessable entity status code and the validation error saying category ID 100 does not exist. Awesome, so our update product endpoint is working with all validations we added on the product model. Now to complete our product CRUD operations, we need to add a delete endpoint, so the client can delete a specific product by its ID. So back on the product controller file, let me hide the update product function, and below we'll create a new function. So export dot, and we'll call this delete product, which is equals to the same functions from other routes, async handler, the async, request, and response parameters, arrow function. Okay. Now inside, this will be exactly like the delete category function from inside the category controller file. So what I'll do here is copy the entire content and paste inside the delete product function. Perfect. Now instead of the category here, we rename it to product, and then the product model instead. Then the if statement checking if the product constant instead. Here on the error property, we rename it to product not found. Here we're gonna call the destroy method from the product instance. Okay, so here we're getting the product by its primary key, which the client will send on the route parameter, and we're gonna call ID as well. Then we're checking if the product exists. If not, we're returning the 404 status code with the error message saying product not found. Otherwise, we're deleting the instance of that product by calling the destroy method from Sequelize. And lastly, we're returning the 204 no content status code to the client. Okay, very simple. Now let's create the route that we'll call this delete product function. So inside the product route file, below the patch update route, I'll add router dot, and this will be a delete route. And for the name, will be the same as the patch and the get by product ID route. So slash column, and for the parameter, we're expecting the ID as well. And then call the product controller dot, and select the delete product function. Perfect. Now let's test this new endpoint on Postman. I'll open a new request tab, and the method, I'll select delete, and the URL is http column / localhost port 3000 / product / and let's delete the product that we created for testing. So here on the get products tab, if we click on send, here are all the products, and the test product is ID number 6. So here on the delete product request, I'll add the product ID 6 as a parameter and click on send. And perfect, we got the 204 no content status code and nothing on the response body. And to make sure the product was deleted, let's open the get products tab again. So the test product is still here, but if we click on send, and perfect, it's not there anymore. Great, so our delete endpoint is working. Let's just test a validation here and add a product ID that doesn't exist. So I'll add 100 here on the parameter, click on send, and great, we got the 404 not found status code and the error message saying product not found. Perfect, everything is working. So we completed our REST API CRUD operations for categories and products. But let's add more features to our API. For example, the client might need an endpoint to return products by a specific category. So in that case, the client will pass the category ID on the route. So let's create this new function inside our product controller file, since we're going to return products on the response. So below the delete product function, I'll add a new function. So export dot, and let's call this get products by category ID. And it's also equals to the async handler, the async request and response parameters, the arrow function, just like for the other functions. And inside, first thing we need to do is grab the category ID that the client will send from the parameters. So I'll create a new constant here and an empty object equals to the request parameter dot params. And from the parameters, we're going to expect a category ID. Of course, the name of the parameter is up to you. Just make sure to add something related to the context. Now what we need to do is check if a category with this ID exists. So I'll add an if statement, and I'll add an exclamation sign, and I'll check directly here inside the if statement. So await the category model dot, and we're going to use the find by primary key method. And inside, I'll add the category ID that we're extracting from the request parameters. So if the category wasn't found, let's return response.status, the 404 not found status code, and a JSON response with an object, and inside the error property saying category not found. Now, if the category was found, we need to find all products where the category ID field is equals to the category ID parameter. So I'll add a new constant called product equals to await the product model dot, and we can use the find all method and add an object to configure some properties inside. And we can configure the where property. This where property is used to filter results, just like the where clause in SQL. And this is equals to an object. So we want to filter all products from a specific category ID. So in this case, we can say that the category ID field from the products model is equals to the category ID from the request parameter. But since the key name is the same as the value name, we can leave just one category ID here that JavaScript will understand. Okay? And what we can do is return the category object with the ID and the name and exclude the category ID field just like we did for the getProducts and getProductById functions. So let me copy the attributes and the include properties here and paste inside the getProductsByCategoryId function. Great! Now all we need to do is return the products constant to the client. So return response.status, and we're going to return the 200 OK status code and a JSON response with the products constant inside. Awesome. Now let's create the route that will call this function. So on the product route file, below the delete route, I'll add router dot, and this will be a get route. Actually, let me add this route next to the other get routes we have. Okay, and the name, we can add something like slash category slash column and the category ID parameter. So the route will be products slash category slash category ID. Of course, the route name is up to you or your team. Just make sure it's clear and consistent. And this route we'll call the product controller dot the getProductsByCategoryId function. Awesome, let's test this new endpoint on Postman. I'll open a new request tab here. And the method we can leave as get. And the URL is the same, http ://localhost port 3000 /product /category and let's use the electronics category ID, which is 1. Okay, click on send. And perfect, we got the 200 OK status code and all the products that has the electronics category with the category object here. Great, let's test with another category. So I'll add 2 here on the parameter, which is the accessories. Click on send. Okay, we got the 200 OK status code and an empty array. That means we don't have any products with the accessories category. And this is the correct response we should return. That means the category ID was found, but there are no products to return. And if we check here on the Create Product Request tab, we did create a product with the category ID, but we deleted. So let's create this product again by clicking on Send. Okay, product created. Now back on the getProductsByCategoryId request. Let's leave the product ID 2 here on the parameter and click on Send. And perfect, it returned the test product, which has category ID as 2 accessories. Awesome. Now let's test with a category ID that doesn't exist. So I'll add 100 here, for example, and click on Send. And great, we got the 404 not found status code and the error message saying category not found. Perfect, so we completed the getProductsByCategoryId endpoint. Now one last feature I like to add is on the delete category endpoint inside the category controller file. So now we're just deleting a specific category but not checking if products are used in this category. So for example, here on Postman, let me open the delete category tab and let's try to delete a category that's been in one or multiple products. For example, the electronic category, which the ID is 1. So if we click on send, we got the 500 internal server error status code, and the generic error message saying something went wrong. We should definitely send a better response to the client, informing that the specific category the client is trying to delete, one or multiple products are using. And we can even send how many products are actually using it. And of course, sending the correct status code instead of the 500. So if we check here inside the terminal, Sequelize returned a foreign key constraint error. And up here on the details, it says that the category ID 1 is still referenced from table product. Okay, let me close the terminal. So here inside the delete category function, first we're gonna check if the category ID exists, just like we already have in here. And next, we're gonna add another validation, checking how many products are actually using that category. So below the first validation, I'll create a new constant, call product count, which is equals to await the product model. And we can import directly from the models folder. Okay, let's just check here on the top. Okay, product was imported below the category model. Now back on the delete category function, here we can call the .count method. This method is used to count the number of records that matches a certain criteria. So what we can do here is add an object and set the where property, which is also equals to an object. And we want to search for the category ID field inside the product table, where is equals to, and here we can use the request parameter .params.id, which the client is sending on the route. Or since we have the category instance here, if it exists, we can add the category instance .id. So both ways works fine. Personally, I prefer to use the instance like this, cause in my opinion is more readable and semantic, less repetition, cause request.params.id was already used to get the category, and safer cause if we ever need to transform or validate the category.id field, it's already ready to use. So I'll leave it like this, but feel free to use the request.params.id if you prefer, okay? So next, let's check if the product count constant is higher than 0. So I'll add an if statement and add the product count. And we can leave just like this because the count method returns a number. And in JavaScript, 0 is falsy and any number greater than 0 is truthy. So if product count is greater than 0, let's return a response to the client. So I'll add return the response parameter .status, and here we can use the 409 conflict status code because the client is trying to delete or modify a category that's still in use by product. That creates a conflict with our API rules. And let's also send a JSON response with an object and the error property. And now I'll add backticks here, and let's send something like category ID is being used in, and here let's return the product count constant to the client. So $sign in curly braces, the product count constant, and let's add products like this. Great. And if the product count is 0, that means the category is not being used. Then we can proceed with the delete. Awesome. Let's test this route on Postman. So I'll just click on send here as we already tried to delete the electronics category. And perfect, we got the 409 conflict status code and the error message saying category ID is being used in 4 products. Now just to make sure, I'll create a new category here on the create category request tab. So here inside the body, the name I'll add as test category, for example, and click on send. Okay, the new category was created with ID 11, and back on the delete category request tab, let's add the ID 11 as a parameter and click on send. And perfect, we got the 204 no content status code. That means the category was successfully deleted. Awesome, so we completed our products and categories REST API using Sequelize, using the REST best practices, returning the correct response and status code to the client, adding validations and many other good practices. Until now, we've let Sequelize create our database tables automatically based on the models using the sync method. This is helpful during development since we're constantly changing our models and adjusting the database structure. However, once we move to production, or even when we finish our first stable version of the API, it's a good practice to switch to migration scripts and remove the sync method. This is important because migrations give you full control of your database changes. Think of it like this: instead of letting Sequelize guess what your database should look like, you define every change step by step. That means you can keep track of how your schema evolves over time, safely apply or even roll back changes across different environments like development, staging, or production, work with other developers without worrying about someone's model changes breaking your database, and most importantly, you avoid accidental data loss, which can happen if you use things like the sync method. So from this point forward, we'll use the Sequelize CLI to create and manage migrations. This makes our app more stable, predictable, and production ready. So to start using Sequelize CLI, first let's install as a development dependency in our project. So on the terminal, make sure to stop your app by pressing Ctrl+C and then type npm install Sequelize-CLI and add the flag --save-dev. This will add the CLI to our project, so everyone who installed the dependencies will have the same version. Hit enter. Okay, Sequelize CLI is installed, and if we check here on our project.json file, we can see that Sequelize CLI was added to the dev dependencies object. Okay, now to initialize a new Sequelize CLI project, here on the terminal, let me clear, and we can type npx, which differently from npm, this is a tool that lets us run Node.js packages directly without installing them globally. Then Sequelize-CLI, followed by the command init. We could run this command directly without installing it first, but it's a good practice to install it as a development dependency. That way, the specific version of the CLI is saved inside our project, and everyone who clones the repository will use the same version when running commands. Okay, hit enter. Great, Sequelize CLI was initialized, and note here on the terminal that it created a file named config.json inside our config folder. And here it is. I'll explain what this file is in a moment, but note that if we didn't have the config folder on our project, Sequelize CLI would create it automatically and add this file inside. And below here it says that the models folder already exists. That means if we didn't have the models folder, Sequelize CLI would also create it for us. And then below it says successfully created the migrations folder and successfully created the seeders folder as well, since we didn't have these folders before. As we can see here on the Explorer, let me quickly explain what these folders are. So migrations we'll use to store scripts to create and modify database tables. So since we have 2 tables in our database for now, we need to create scripts to create these tables. And later, if we need to create more tables or manipulate columns on the existing tables, we can add these scripts inside this folder. The seeders folder we can use to store scripts that insert initial or sample data into our database. We're not going to use this folder on this tutorial, but a good example, let's say we have a users table in our database, and to access our application, we need a valid user. So we could create a script inside the seeders folder to insert a new user like admin user or a demo user. That way, we'll have a user to access the application. The models folder, we're already familiar with this. It contains files that represents a database table like we have for the categories and products. And note that Sequelize CLI created this index.js file here, but I'll explain in a moment what this file is. And let's understand this config.json file that Sequelize automatically generated. This file is used by Sequelize CLI to know how to connect to our database when running commands like migrations or seeders. As you can see here, Sequelize CLI allows us to define database settings for different environments. By default, it includes 3: development, test, and production. This separation helps when we want to connect to different databases depending on where our app is running. For example, a local database during development, a temporary one for automated tests, and a live database in production. Of course, we can create additional environments if our project workflow requires it. It's important to know that this file is used only by Sequelize CLI. Our main application can still load its own database configuration, usually from environment variables inside the .env file, like we did here on the database.js file. Now, one important recommendation, instead of keeping this file as config.json, it's a good idea to rename it to config.js. That's because JSON files are static, they can't read environment variables or run any JavaScript logic. By renaming it to .js, we can load our .env file and use variables that we created for establish a connection to our database, keeping our credentials secure and flexible. So what we can do now is load our environment variables by typing here on the top, require, and inside .env, and here on the end, .config function. And we can export this entire configuration object here by wrapping inside a module, .export, equals, and now we can use any of these environment settings in other files if we need. Now here on the development settings, instead of having static values, we can grab from our .env file. So what we can do here is let's copy the Sequelize connection configuration here from the database.js file and replace here on the development object. Great, these settings are the same of a Sequelize configuration. And I'll actually replace all the environments here with the same configuration. We don't have a test and production environment, but I'll add it anyway. For the production environment, it's not recommended to log on the console the queries our application is calling. So for the login property, let's change it to false instead. Now you might be wondering why I added the same configuration for everything here. That's because in most projects, each environment will have its own .env file, containing its specific database settings. For example, our local .env file might connect to a database on our own machine, while the one used in production will point to a cloud database with different credentials. By keeping the same configuration structure for all environments inside the config.js file, we can easily switch between them just by loading a different .env file, without changing any code. And just to clarify, these keys, development, test, and production are directly linked to an environment variable called Node_env. So here on the .env file, right at the top, let's add the Node_env variable and set to development. Whenever we run a Sequelize CLI command, it automatically checks the value we added here to decide which configuration to use. If we don't manually set this variable, Sequelize defaults to the development environment, which is why, during local development, we can usually run commands without worrying about it. But it's a good idea to add it here, just to make it explicit and avoid confusion later when we move to staging or production. Okay, so up until now, we have our database configuration written directly inside the database.js file, where we manually set in all the parameters using our environment variables. But notice that we already have the same configuration inside our config.js file, which is used by Sequelize CLI. That means we're basically duplicating the same setup into two different places. So instead of keeping both, we can make things much cleaner by reusing the configuration we already have. So here inside the database.js file, let me remove everything we have inside the Sequelize object, because we're gonna get it from inside the config.js file. So let's import here below Sequelize the config.js file. So const config equals to require // and select the config file. Okay, next we need to get the environment we're currently in. That's the value we stored in our .env file inside the Node_env variable. So I'll create a new const here on the top, call environment equals to process.env.node_env. Now, in case we haven't defined this variable anywhere, I'll add an OR operator, that's the double pipe, and set a default value of development. This means that if node_env is not defined, our app will automatically use the development environment. Great, now inside the Sequelize settings object here, we can actually remove this object from here, and instead call the config, we import it on the top, and an array, and inside pass the environment constant. So this will get the settings from the config according to our node_env variable and return the connection details. Let's just make sure the connection still works. So here on the terminal, I'll just type npm start and hit enter. And great, database connected and synchronized. Perfect. So continuing, we changed the config here from .json to .js, but Sequelize CLI by default, it will look for a config.json file. So we need to tell Sequelize CLI to look for the config.js file instead. For that, we need to create a new file here on the root, called .sequelize rc. This is a configuration file that tells Sequelize CLI where to find or store certain folders and files, like our models, migrations, seeders, and the config file as well. So inside this file, here on the top, I'll import the path package, which already comes built in into Node.js. So const path equals to require, and inside path. This package helps us work with file and folder path in a safe way, no matter which operating system we're using. We'll use to tell Sequelize CLI exactly where our config file is located. So below here, we need to add module.export equals to an object, and inside we can set the config property and tell where the config file is. So for this, we can use the path package, which is imported, .resolve method. This method is used to create an absolute path for a sequence of path segments. For example, inside here, we can say that the config.js file is inside the config folder, and I'll add a comma and add the config.js file. Great! Now by default, Sequelize CLI looks for the models, migration, and seeders folder inside the root of our application. So we don't need to change anything related to these folders, but if we had the models folder in a different place, for example, we can add the models-path property, and since we're using dash on the property name, we have to make it as a string and add single or double quotes. And let me add on the config property as well to make it standard. And here on the models path property, we can set the correct directory by using the path package, just like we said here for the config file. And same for the migrations folder, so we can add migrations-path, and also for the seeders folder by setting the seeders-path property. Okay, very simple. But since we don't need to configure these folders because they're already on the root, I'll comment these and leave just the config. Great! So far, we've only set up the Sequelize CLI to work not only with migrations, but also to work with seeders if we need to in the future and other tools that Sequelize CLI offers. So our Sequelize setup is complete, and to make the most of the features that Sequelize CLI offers, what I'll do is completely remove our database so we can create everything from scratch. So here on the Beaver, I'll select our database, right click, and select the delete option. Confirm, and great, our database is removed. Now here on the terminal, we can create our database using Sequelize CLI commands. So let me stop the server by pressing Ctrl+C, and then clear. And the command to create our database is npx sequelize-cli db column create. This command will create a database with all the settings we set here inside the config.js file, which is set here on our .env file. for the development environment. So we can hit enter, and perfect, the database Sequelize with Node.js created. So here on the Beaver, let's refresh the databases folder. And there it is, our Sequelize with Node.js database. And of course, this is a complete empty database. So if we open the database, for example, in schemas, public, tables, you'll see that there are no tables yet. That's because we're going to use the Sequelize CLI migrations to create the tables step by step. And just one note, let's avoid calling the npm start command here on the terminal to start our application, because since we're using the Sequelize sync method here on the index.js file, our tables will be created on the database based on the model files we have. And we want the migration files to handle this for us, because we want a history and version control of every change we make on the database. Soon we'll be back on this file to remove this method from here and start our server in a different way. So let's create our first migration, and let's start by creating our categories table. So let me clear the terminal, and let's type npx sequelize -cli, and the command to create a migration is migration column generate. And we need to add the flag -- name. This flag is used to give our migration files a descriptive name, so we can add here create -categories. Make sure to add a name that describes what the migration does, making it easier to identify, like add column to a table, remove column from a table, something like that. It doesn't affect how the migration runs, it's just for clarity and organization. Okay, hit enter. And great, new migration file was created at this path. So if we check the migrations folder, note that we have a new file with this structure here. Every Sequelize migration file has an up function and a down function. The up function defines how should happen when the migration is applied, and the down function does the opposite. It defines how to undo the migration if we ever needed to roll it back. And notice that inside both functions, we already have an example here. Let's remove these comments to make it clearer. So in this example, we're using the query interface object to create a table called users and defining the columns here. In this case, just the ID as integer. The query interface object is really powerful. It gives us access to several helper methods that let us interact directly with the database schema. We can create a table, remove a table using this drop table method here inside the down function, add, update, or remove columns, create indexes, and constraints. Basically everything we need to involve the database structure in a controlled and versioned way. So let's change this method here to create our categories table, and instead of users we can replace with categories. And the second parameter here is an object which defines our categories table structure. So let me format here, because we're gonna add more fields, and we can keep the ID here, but we're gonna change this to an object because we're gonna add more properties. For example, the type to define this field type, and equals to the Sequelize parameter, dot, and select the integer type, because if we check in our categories model file here, the ID column type is integer, and we need to tell Sequelize that the ID column is also the primary key, auto-incremented, and does not allow new values. And these properties are the same between the model and the migration. So what we can do is copy these properties from the model and paste inside the ID property on the migration file. Perfect. Let me format. Okay, so we have the exact same properties from the category model file. Now let's go back to the model file again. Let's do the same for the name field. So here we have more properties besides the type and allow new, like the unique and validate. So I'll just copy the entire name object for now and paste inside the migration file below the ID. Let me format here. So the name has the unique and validate properties. But inside the migration, we should not deal with validations, so we can remove the validate object from here. And for the unique property, we should just replace to true instead of an object. So let me select here and replace it to true. So we have the type, allow new as false because it's a required field, and the unique property to not allow same category names. And here on the categories model file, we added the timestamps property as true. That means we have the created at and updated at columns. But since we're not going to use the Sequelize sync method anymore, we need to add these columns manually on the integration file. And the name of these columns must be snake case, because we added the underscored property as true, so the words must be separated by underscore. So back on the migration, below the name field, we can add created underscore at equals to an object, and the type here is equals to Sequelize dot date type, and let's also add the allow new property equals to false. And we can add the default value property, which defines a default value that will automatically be set in the column if no value is provided when inserting a new category. So here we can call the Sequelize parameter dot and use the fn method, which stands for function. This is a helper method that let us call database functions like now, count, max, lower. So inside here, we can use the now SQL function to get the current date and time. Okay? Next, we need to add the updated underscore at column, also equals to an object, and it will have the same properties of the created at column, type, allow new, and the default value with the current date and time. So let me copy all these properties from here and paste inside the updated at object. Perfect. So our up function to create the categories table with its columns is complete. Now here on the down function, let me remove these comments from here. And if we need to go back a version of our migration, we need to remove the categories table. So we can keep the drop table here and replace the users to categories. Perfect. Now we have our first migration file created using Sequelize CLI. So let's execute this migration so Sequelize CLI can create the categories table on our database. Back on the terminal, let me clear and type npx sequelize -cli, and the command to execute our migration file is db column migrate. This command is used to apply all pending migrations to our database. So basically what it does is check if we already execute a migration inside the migrations folder. If so, it will ignore it and only execute new migration files. So let's hit enter to see what happens. Okay, so we got an error here saying data types is not defined. That's because here on the migration file, we copied it from the model file, but we don't use data types here. Instead, we have to use the Sequelize parameter, just like for the other fields. So let me copy from here and replace on the name type. Okay, so in the model files, we use data types from Sequelize library, and on the migration file, instead is the Sequelize from the parameter. Okay, let's try again on the terminal. Let me just double check here on the migration if everything is good. Okay, so I'll execute the db migrate command again. And perfect. We can see that executes a create table categories SQL command here on the terminal and other commands that Sequelize CLI needs. Now let's check our database on dbeaver, refresh the tables folder, and perfect. Here's our categories table with all the columns we defined in the migration file, ID, name, created at, and updated at. And note that it created a new table called Sequelize Meta. This table is automatically created by Sequelize CLI whenever we run migrations. It's a tracking table that keeps a record of all the migrations that have been executed. Sequelize uses to know which migrations have already run and which are still pending. So let's check the data inside. And note that we only execute one migration, which is the create categories. I forgot to mention that this number here in front of the migration file name, it's a timestamp that helps order migrations chronologically. This ensures that when we run migrations, they are applied in the correct sequence. So the command we used earlier, db column migrate, executes the up function of all pending migration files to update our database. But when does the down function run? It runs whenever we want to undo a migration. For example, in the terminal, let me clear, we can type npx sequelize-cli and the command db :migrate :undo. This command will roll back the last executed migration, running its down function and updated the Sequelize meta table so Sequelize knows it's no longer applied. So let's hit enter just to check what happens. Okay, now let's check on dbeaver and refresh the tables folder. And notice that the categories table was deleted, and if we check here inside the Sequelize meta table, so here's the old record of the create category migration. Now if we refresh, the create categories migration record was removed. Now to create the categories table again, all we need to do is execute the migrate command again like we did earlier. Great, let's check again on dbeaver, refresh the tables folder. Okay, the categories table was created again, and if we refresh the data here in Sequelize meta table, the create categories migration was inserted again. Awesome! Now an important rule when working with migrations is never modify the database directly to change a table, and never edit a migration file that has already been executed. That's because migrations are version controlled snapshots of our database schema. Changing the database manually or editing old migrations can cause inconsistencies, break other team members' environments, and make it impossible to roll back safely. Instead, if we need to update a table, we must create a new migration file describing the change. For example, adding a column, changing a type, or adding an index. This way, everyone can apply the change in a controlled, predictable way. Later on the video, we'll create a migration file to change or add a column. But first, let's create another migration file, but this time to create the products table. So on the terminal, let me clear, and let's call the npx sequelize-cli, the command migration, column generate, and add the name flag, and let's call this migration create-products. Hit enter. Perfect, a new migration file was created inside the migrations folder with the up and down functions that we are already familiar with. So let me remove the comments from both functions. And here on the up function, I'll replace the users here with products. And also here on the down function, products, because this will be similar to the categories migration file, and we'll use the same Sequelize methods, create table and drop table. Now let's configure the columns we have inside the products table. Let me format here. Okay, let's check the products model file. So let me copy the properties from the ID field here. And back on the create products migration, let's replace the Sequelize integer to an object and paste the properties inside here. Perfect, now let's replace the data types here to Sequelize. Great, now back on the product model file, let's copy the entire name object and paste below the ID object. Okay, let's replace the data types to Sequelize and remove the validate object. Okay, let me format. Great. Now back again on the product model file. The next field is the description, so let me copy from here and paste below the name object. So the description is very simple, we only need the type. So instead of an object, we can say that the description is equals to Sequelize parameter dot text type directly without adding the type inside an object. And next, we have the price, so let me copy from here and paste below the description. Okay, let's format and replace the data types to Sequelize and remove the validate object, leaving just the type and all new. Okay, next we have the currency, so let's copy and paste below the price. Format, replace data types to Sequelize, and remove the validate object. Perfect. Next, let's copy the quantity, paste below the currency, format, replace to Sequelize, and remove the validate object. Okay, let's continue. So back again on the model file. Next field is the active, so let me copy the entire object and paste below the quantity. Let me format, replace data types to the Sequelize parameter, and remove the validate object. This task is a bit repetitive, but we're very close to wrapping it up. Back again on the model file. Now we have the category ID, which is the foreign key, so let's copy the entire object and paste below the active field. Okay, first let's format, replace the data types to Sequelize, just like for the other fields. We can leave the allow new property, and to make the relationship with the categories table, we should leave the references property here configured exactly the same way, with the model and the key properties inside. But here on the model property, the migration can't read from the category model file like we're adding here. So instead, we need to add explicitly here the name of the table the field is relating to. So we can add categories in lowercase, and the key we can leave as ID, which is the category table field is relating to. And then we can remove the validate object. Great. And last, we need to add the created at and updated at columns, because we added the timestamps property as true. So what I'll do is copy both these columns configuration from the create categories migration file and paste below the category ID column. Perfect. The product migration file is complete. Now let's execute this migration on the terminal. So I'll clear and type npx sequelize -cli db column migrate. Hit enter. Okay, create products migrated. Now let's check on dbeaver. I'll refresh the tables folder. Great, here's the new product table with all the columns we added. And if we check here inside the foreign keys folder, notice that there is a foreign key created here for the category ID column, and we can view the details of this foreign key by right-click on it and select View Foreign Key. And here we can see the associated entity, which is categories, and below here on the reference column is the ID. Perfect. Now let's check the Sequelize meta table. Let me refresh. And perfect. Here are both create categories and create product migrations. Great. Now back on the terminal, let's run the command to undo the migration. So npx sequelize -cli db column migrate column undo. Okay, this command, it will only convert the last migration we executed. So here on the dbeaver, I'll refresh the tables folder. And notice that only the products table was removed. Also here on the Sequelize meta table. Great, and we can execute the db migrate command again to create back the products table. Okay, let's check. Perfect, all good again. And on the Sequelize meta table as well. Awesome, so we completed our migrations using Sequelize CLI. And before we test our API to make sure everything's working, let's make a change here on the index.js file, because we are using the sync method here that will create our database structure for us based on the model files. But the issue with using this method is that it's not reliable for real projects. Every time we run it, Sequelize tries to match our models with the database, and depending on the options we use, it can end up dropping tables or changing columns unexpectedly. Another big problem is that it doesn't give us version control. If someone else on our team makes a model change and runs sync locally, their database will be updated, but yours won't. And that creates inconsistencies between environments, so make sure to always use migrations, especially in a team environment. So here on the index.js file, we don't need to call the sync method anymore. We can call just the app.listen function outside the sync method, like this. But if you still want to check if the database connection is valid before starting the application, so let me put everything back. And what we can do, instead of calling the sync method, we can call the authenticate method. The authenticate method simply tests the database connection. It tries to open a quick connection using the credentials we added on the database.js file, and if it succeeds, it means the database is reachable and the configuration is correct. And then we can start our app. Let's just remove this and synchronized, because we're not doing synchronization anymore. Okay? And if there is any issues with the connection, we can add the .catch method here on the end, and this returns a error parameter, arrow function, and we can write something on the console, so console.error, and let's add something like error connecting to the database. And I'll add a column here and a comma and add the error parameter. Great! Now let's test our application again. So here on the console, let me clear, npm start, and note that Sequelize tests the database connection by executing this simple query here. Select 1 plus 1 as result. And if this query is executed and return a result, in this case 2, the database connection is established. And then we're showing database connected and server started on port 3000. Perfect. Now let's test our API on Postman. So let's just create a category, test if it was inserted, and let's create a product using that category and call the get endpoint for all products. Very simple. So I'll open the create category tab here on the beginning. Okay, and on the body tab, I'll add electronics, for example. Click on send. Perfect, we got 201 created status code and the new category details on the body. Let's quickly check on dbeaver. Right click on categories, view data, and there it is, the electronics category. Now back on Postman, let's open the get categories tab. Click on send. Great, it returned the electronics category. Now let's create a product. So on the create product tab, open the body tab. Let's add the name as laptop. The price we can leave as 100 and the quantity equals to 10. And the category ID, let's change it to electronics category we just created, which is 1. Okay, let's just send these details. Click on send. Okay, so we got an error here, and if we check our code, we got a database error on the terminal. That's because we created the category ID field as camel case. We can see it here on dbeaver, category ID, but in the product model file, we added the underscore equals to true. So it expects a snake case category underscore ID field. But here on the migration, we created as category ID camel case. So to fix this, we need to create another migration file to rename the category ID field to snake case, instead of change it directly in the database or change the migration file. So here on the terminal, let me clear, and type the command npx sequelize -cli migration column generate to generate a new migration file, and the -- name flag, and let's add something very descriptive here, like rename -category ID in camel case -to -category underscore ID, and then I'll add -in -product. Of course, the name of these migration files is up to you, but once again, make sure to add a very descriptive name here. If we're changing multiple columns or adding multiple columns, we don't need to list all of them here on the name, but since we're only renaming one column, it's okay to add it here. Okay, hit enter. Perfect, new migration file is created with the same structure, up and down functions. And let me remove all the comments inside both these functions. Okay, now here on the up function, instead of calling the create table function, we can call the query interface.rename column function. These functions rename a specific column from a table, so the first parameter is the table name, the second parameter is the current column name we want to change, and the third parameter is the new name we want to apply for this column. So here instead of users, we replace to products, and the second parameter is the current column name we want to change, so category, ID in camel case, and the third parameter is the new name of the column, so category underscore ID. Perfect, very simple. And for the down function, we're gonna do exactly the same thing, but the opposite. Change it from category underscore ID to category ID in camel case. So let me copy the entire code we have on the up function and paste in the down function. But we're gonna do the reverse here. So the second parameter is the category underscore ID. Change it back to category ID in camel case. So this is a very simple migration file. Let's run this new migration on the terminal. So let me clear and run again npx Sequelize CLI db column migrate. Great, let's check on dbeaver. So here on the products table, we have our old column category ID in camel case. Now let's refresh the products table. And perfect, it changes to category underscore ID in snake case. And let's check on the Sequelize meta table. Let me refresh down here. And here it is, the new migration we just executed. Now let's test the endpoint again on Postman. I'll just click on send. Oh, sorry, we need to run our app. So back on the terminal, let's type npm start. Okay, all good here. Back on Postman again. I'll click on send. And perfect, we got the 201 created status code and the new laptop product details on the response body. Now let's call the get products endpoint. Perfect, here's the laptop product details with the electronics category details on the response. Awesome. Now before we wrap up, I forgot to mention one thing. When we ran the Sequelize init command, it also generated this index.js file inside the models folder. This file is basically an autoloader created by Sequelize CLI. Its purpose is to automatically load all the models in this folder, initialize them, run their associations, and then export everything from a single place. For example, if we open our product controller, you'll notice that we imported each model directly. But using that autoloader file, we could instead write something like const, an object, and I'll add the product, and category models equals to require, and inside // the models folder. This would work because index.js will return an object containing all the initialized models. However, this is the old Sequelize pattern and is not used much anymore. In our current setup, each model imports the Sequelize instance directly and calls the sequelize.define function inside its own file. Because of that, we're manually organizing and loading our models, and we don't rely on the automatic loader. So in practice, the index.js file isn't necessary for our project, and we can safely ignore it, or better yet, we can remove it from our project to keep the folders clean. And just to make sure our app still works, we can check here on the terminal that nodemon restarted our server, and here on Postman, I'll just call again the get products endpoint, and great, everything's still working without the index file. Perfect, so in this video we learned how to build a complete REST API using Sequelize to connect to our PostgreSQL database. We also learned how to handle errors by abstracting them into a separate error handler file, and we did the same for async functions using our async handler wrapper. This keeps our controllers clean and allows us to avoid writing repeated try-catch blocks everywhere. And we also learn how to use Sequelize CLI to create and run migrations. This gives us full control over our database schema and makes it easier to version, update, or roll back changes in a clean and consistent way. I'll leave the GitHub repo link for this entire project on the description below. Hope this video was helpful to you, and if it was, please click on the like button and subscribe to the channel. Thank you so much for watching and hope to see you on the next video.